Welcome to this course, which is all about helping you to become an advanced blockchain developer and to teach you something to build something meaningful softwares in a blockchain. So in this lecture, I am going to give you all around introduction to this course. Okay, so first of all, let me introduce myself. So my name is Rohit Sonaune, and I am a blockchain developer and consultant, and I have 7 years of experience in software development and consulting. I have a good knowledge of and expertise in crypto currencies, Solidity, Ethereum, smart contracts, and AngularJS. Okay, so I think that I can give you the best learning curve for this blockchain development. Okay, so before we start into this course, so within the next lectures, I just want to make sure that you will be aware, you should aware of the key things that will be required for this course. So I have structured this course in such a way that it is well paced for everyone to ensure that they feel fully comfortable to learn this course. So by end of this course, you will be learn to develop some crypto related things. Okay, and we will be diving into in-depth in this course for an exchange for crypto, right? And we will learn in this course is that we will learn about the workflows and ecosystem of a blockchain, the basics of a blockchain, and how the distributed complex applications actually built in the blockchain that we are going to learn in these things. Also, we are going to learn about the setups like for truffle and configurations needed in order to run your programs in a private blockchain network. Okay, we are also going to look at the things like truffle test framework and the testing framework that the truffle provides. We are going to write down some tests to check out our program or whatever maybe the smart contracts. Okay, and at the end we are going to work with the front end. In that we are going to see that how we can connect the front end technology like your JavaScript or your React or any AngularJS things to your smart contracts. And for that we are going to use a Web3.js library that we are going to use in this course also. So also we are going to learn about events and interaction between smart contracts. Okay, and the things like Ganache or Rinkibi. Okay, so we will learn all those things in this course. So this course is well paced for everyone. So in this tutorial we are going to build an exchange. Okay, in that we are going to write down and exchange smart contracts. Okay, we are going to deposit ether or tokens. Okay, we can also withdraw ethers or tokens. Okay, we will write down the functionality for the exchange. Okay, that is very important for the trading, like sell order, buy order. Okay, and we will see the logic of buy order, sell order, and how it is running in the exchanges, okay, all over the world. That all the things that we are going to see in this exchange tutorial. Okay, and so much more just the quite now. Pretty soon, yeah, you will probably not had enough of time to work through these lectures. Okay, and at that point, so you don't feel obliged to leave review if you haven't covered enough of this course. Okay, so reviews are always welcome, but leave the review after watching all the course videos, so your feedback will be better, and that feedback will help us to make better courses in the future. Okay, so that's it for this course introduction. So we look forward to seeing you in the next lectures. We will meet in the next lectures. Thanks for watching. Hello everyone. So in this lecture we are going to see what is a blockchain, and in this session we are going to cover the basics of a blockchain so you can understanding the foundation of a blockchain, so you will understand the future coding and the syntax that we are going to write down in this course. So let me start with the what is a blockchain. So if you're I think if you are doing this course, you must probably know what is a blockchain is all about, but let me explain a little bit amount of data for this. So what is a blockchain? So blockchain is a type of a distributed ledger for maintaining a permanent and a tamper-proof record of transactional data. A blockchain functions as a decentralized database that is managed by computers belonging to peer-to-peer network. So what is actually this definition is all about? Okay, if we are going to see this slide, here you can see different types of networks here. So this is centralized, decentralized and distributed networks. Okay, these are some new networks that are present right now in the world. So what is the difference between the centralized, decentralized and distributed system? So in centralized system, all you know is that every node or every computer in that network is connected to some centralized system or some centralized server. So that's why it is called a centralized system. So in today's world, many of the systems that we are using over the internet are centralized system. Means that there is some server like for like some Google server at some central location, and we are accessing that central database of a Google from our computer. So that is a centralized system. Then what is meant by decentralized system, and why it is needed to make a network that is decentralized? So the main problem with the centralized system is that if the server goes down, okay, the central point where we are all connected, if that goes down, we cannot communicate with each other, right? If this central system goes down, then this node cannot communicate with this node, right? Because the central system is down and there is no medium through which I can communicate. So to eradicate this problem, the computer engineer come up with this decentralized system. So in decentralized system, as you can see here, there are different types of nodes here, right? And there are some little networks you can see here. Okay, and those little networks are connected to their some centralized smaller server, you can say. Okay, but the decentralized system has also a problem of the failure for particular nodes. Like if this node wants to communicate with this node, okay, but this node goes down, then this node cannot communicate with this node. So this is the problem with the decentralized system. But advantage is only that all the network does not goes down, okay, if there is a failure of some node in the decentralized system. Okay, that is the benefit that we get in the decentralized system. So to eradicate this problem also, the network engineer comes up with the distributed system. So this in the distributed system, as you can see that everything is connected to everything. Means every node is connected to every node, and there are multiple routes by which they can communicate with each other, right? So if, for example, if this node wants to talk with this node, okay, and for example, if this node goes down, still this node can communicate through this node with this, right? So in distributed system, the network never goes down, okay, and every node can communicate with each other, and there will be no effect of a particular node if goes down. So network still will be alive. So that is the benefit of the distributed system that we get in distributed network. So what is a blockchain is all about? So blockchain is a decentralized and a distributed at the same time. Okay, So it is a decentralized, so there is no particular central server present in the blockchain, and it is distributed also, means every node is connected to each and every node through some network over the internet. So if a particular PC goes down or a particular node goes down, still there will be no problem in a blockchain, okay, to get a data or to send a data. Right, so this is the main difference between centralized and the blockchain systems, you can say. So as we can see in the next slide also, here you can see the same image with the computers, and the network is a distributed system, right? So here you can see it's a shared public ledger, okay, of transaction. So this is the shared system, it's a public, so anyone can see a data on a blockchain, okay, and a ledger of transactions. So each and every node has updated transactions and ledger, right? So if I download the blockchain node into my computer, I can also see the transactions of a particular person, because blockchain is a public thing, right? So anyone can inspect the transactions. So there is no hidden type of things in a blockchain. So it is all transparent and no single entity controls. So the best beauty of a blockchain is that no a particular company and there is no particular owner for a blockchain system. Means that there is no company, there is nothing that owns this system, okay, and that is the beauty of the blockchain, that no one owns the system and still it goes on, right? So we will look a little bit about history of a blockchain. So where is it come from, and who developed this, and how it came into the existence. So in 2007, a person named Satoshi Nakamoto begins the working on this concept called Bitcoin, right? In 2008, he published a white paper on a Bitcoin, and after that he started working on this concept called Bitcoin. So as many of you know the Bitcoin and what is a Bitcoin is all about. So Bitcoin is just a cryptocurrency that people trade for fiat currency. Okay, that is just a virtual currency, right? In 2009, there is a first transaction that is happened in the Bitcoin, and after that, the Bitcoin journey started from year to year. And as you many of you know, in 2017, Bitcoin price is like about $11,000 US dollars. So after that, the people got attention about this Bitcoin, and they find out what is the technology behind this, because Bitcoin no company owns the Bitcoin, right? And no person owns the Bitcoin company, right? It is an automated system. So people go to that particular protocol of the Bitcoin, they play that particular game of a Bitcoin, and they get the Bitcoins, and after that they trade that system. And people were amazed to see this system, that no person is involved in this system, only end users are present, but in the system no human interference is there, right? So many of the companies and developers get mesmerized by this concept, and they thought that okay, so this can be possible if we get this technology of a Bitcoin. So they researched about this technology of a Bitcoin, and they found out this the underlying technology of a Bitcoin is a blockchain. So after that they think that okay, so blockchain is the foundation of this Bitcoin, so we can also use this foundation for other problems that are present, and those are present right now in the world, and we can solve this problem by using this blockchain technology. So many of the developers adapted this blockchain technology. They researched for this thing, and they found that this technology is amazing. So from last 2-3 years, you will find that many of the applications now are built on this blockchain technology, and in the future you will see many more applications that are going to use this technology, because this is the one of the best technology that you can have. So what are the main companies or the main people that are using this thing, and they are pushing this blockchain technology forward? So the first company is the Ethereum, or the network, you can say, that is Ethereum network. So in this course also we are going to use this Ethereum network. So Ethereum networks are blockchain networks, you can say. So Ethereum networks are used to transfer money and store the data. There are many different types of Ethereum networks present in the world right now. So these networks are formed by the nodes, or you can say computers or servers. Okay, and the Ethereum nodes, you can have multiple or many thousands of computers present, right? And each node is a machine running an Ethereum client. So if you have your machine, and if you are running this Ethereum client, then you can also be a part of this Ethereum network. So anyone can run this client on their PC, and they can be a part of this Ethereum network. So, and each node or each PC will contain a full copy of a blockchain, right? So in this course we are also going to see what is actually an Ethereum network, and how to use this Ethereum protocol to build distributed applications, right? So before that, let me tell you what is actually a blockchain versus database thing, right? Many of the people get confused about what is a blockchain actually, right? So if you imagine, blockchain is nothing but a database, right? So our front end that you see right now in the world, those are done in HTML or in HTML5, React, or AngularJS. Okay, those are also those things which we can use in blockchain also, because at a front end side there is no difference, right? Only at the back end or at a database level there is a difference, right? So we will see what is the main difference between blockchain and database. So first thing is that blockchain and database are same because they save data. Okay, so only difference is that blockchain saves the data in a blocks, okay, and our regular database like in MySQL or MS SQL store the data in a particular centralized data file. Okay, that is the main difference. Okay, but otherwise there is no difference when it comes to saving data on a blockchain or on a database. After that, the flow to store data is the same, right? In a centralized application also, if you want to pull up some data, that time what you do is that you write a query on your computer, and you pass that query to your application server, and then your application server query to your database, and you will get the data back from your application server, right? And the same flow is for the blockchain also, because at a blockchain your computer and your application server are present. Okay, just difference is only at this side. Here instead of database, you will find there is a blockchain, okay, at the back end. So whenever you want to get a data or you want to store a data, that time you do the same flow, that you query for your application server, then your application server query for your blockchain database, and then your blockchain database returns the data to the application server, and then to your computer. So the flow is same for your database thing, or database based application, and the blockchain based application. right? But the huge difference is about the money, because as of many of you know, in the centralized database system, or the database that you used nowadays, like MongoDB, MySQL, MSSQL, okay, those database does not cost any money, but blockchain cost you a money to save particular data on to a blockchain, right? So this is the huge difference between your blockchain and your regular database, because to store a particular data on a blockchain you need to pay a money. So this is the main difference that you will find between your regular database systems and in your blockchain systems. Okay, so what is the cost of that money and other things we will see in the next lectures. Okay, also a blockchain store a record for every change ever made to its state, right? So in a normal database, okay, whenever you have some data like users and balance, okay, in the same table you change those things at the same place, right, like their balances. But in a blockchain we save every state of the blockchain, right? If you see this slide and in this image, this is the initial state, okay, and this is the balances for this user, okay. When first transaction happened, okay, just you can see here that the bill sent $10 to Alex and Jill sent $30 to Andrew, right? So this is the first transaction. So this transaction is separately saved, okay. So this state is different and this state is different, so both these state are saved in the database, in a blockchain. After that, whatever may be the future transaction, those are also going to save in the blockchain as a separate entity. So whenever you want to check, okay, for a particular transaction a hash or a particular transaction data, you can check what is the current state of that system. So this is the beauty of a blockchain, that you will get each and every transaction, and you can check every transaction on a blockchain, right? So what is a block is all about? So in a blockchain, block is all about memory chunks that you can use to store your data and the private keys for that particular blocks, right? So those are only memory chunks, okay, that you can say blocks, okay. So if you look at this example, there is always for any blockchain network, there is always a first block called a zero block or a genesis block, okay. That is a starting point for any blockchain, okay. So that's why it is called a genesis block, and it has a configuration of a how many coins and how many things it will contain in that block, okay. So that configuration is present in that genesis block, okay. And after that, whenever there is some transaction happened on a blockchain, so that time another block is created, okay. And in that block, the previous transactions from the previous block is also saved in that new current block, and the current transaction are also saved in that block, okay. So just like that, for every transaction this process happened again and again and again and again, and all these blocks are connected to each and every one, okay, in a linear manner, right? So that is why it is a block, that is why it is called a blockchain, okay. As I told you that about the genesis block, the first block, okay, right? So we can configure it, okay. So if you want to start your own blockchain network, so that you have to first create this file called genesis.json, and in that file you have to write down some configurations, okay. And after that you can use that file to start your blockchain network. In the mainnet also, at some point someone has created this block 0 or genesis block at some point of time, you can say, okay. And you can also uh, develop, or you can also deploy a private blockchain network using this genesis.json in your computer. Okay, you does not need to go to your main network to publish your apps or something that you want to publish every time. You does not need to go to the public server for publishing, right? Because it costs also money. You can also develop your, or you can also deploy your private blockchain in your PC, and you can test and configure your the apps over there also. Okay, so this is the beauty of a blockchain. Okay, and as I said that the transaction for every transaction, okay, the blocks get added. So who actually mine these blocks, right? So there are some miners, okay, who mines means they validate the blocks, right? And they validate according to the rules or the consensus of a network. Okay, so the miners are the people who check that, okay, the data that we got from last transaction is okay according to the consensus of this network, and if that is correct, then they get rewarded for that also, for that validating that transaction. So this is the beauty of the blockchain, Ethereum blockchain, or Bitcoin blockchain, you can say. Okay, and the most important thing is on a blockchain is that you can't tamper the data. Okay, the blockchain system is hack proof system. That's why all around the world now people are using this blockchain technology, because you can't tamper the data on a blockchain, right? For example, let's say this is the blockchain system, and say everybody or every miner is working on a block 91, right? Okay, but one of the miners, okay, wants to alter the transaction block 74, right? He wants to alter this block 74 transaction, right? So what he needs to do, he have to make his change and redo all the computations for blocks from 74 to 90, and do block 91, that is 18 blocks, right? So an expensive computing. So if you want to alter the data on a blockchain, you need very high mainframe computers to alter the data on a blockchain. But in the real world right now, it is not possible for any computer in the world to alter the data on Ethereum based blockchain, because it is a already huge network. Okay, and you can't afford to alter those data or those transactions on the Ethereum blockchain or any big blockchain network. So this is the main beauty of a blockchain, that it is unhackable, right? So this is all about the blockchain introduction and the history and what is Ethereum network is all about and things. So we will meet in the next lecture. Thanks for watching. Hello everyone. So in this lecture we are going to see Ethereum history and smart contract. So let's get started with the Ethereum history. So as you can find more information on in the internet, so here is the person called Vitalik Buterin in 2013 published a white paper on Ethereum. Okay, and after in the early 2014 Gavin Wood, who described it properly. Okay, and after that in 2015 the Ethereum network or Ethereum blockchain, you can say, launched using crowdfunding, right? So this is the just basic history about the Ethereum blockchain. So what is the main difference between the Bitcoin blockchain and the Ethereum blockchain, right? So what are the features that Ethereum blockchain network provides rather than Bitcoin blockchain or other any cryptocurrency related blockchain networks, right? So these are the some features that you can see in the Ethereum. Okay, so first is the Solidity thing. So the Solidity is a programming language built for the Ethereum. So you can write smart contracts, okay, a smart code you can say, in a Solidity language. Okay, so it is a built-in programming in a Ethereum that you can use to write a code. So this is the first feature you can say in Ethereum. After that, Ethereum is a Turing complete, so it can simulate a computer, and it is said to be the most expressive. Means that Ethereum network acts like the computer. Okay, it runs your code. Okay, it saves your data. It get back to your data. It's secure your code and everything just like that. So it is a Turing complete, you can say. After that, a smart contract. So Ethereum network provides us a smart contract, that is a piece of code running on a blockchain. Means that you can write down a program in a Solidity. You can publish that code on this Ethereum network, and you can interact with that code, and that code is called a smart contracts in the language of Ethereum, right? After that, Ethereum provides us a corruption and tamper-proof system, right? So apps based on the network are formed around the principle of consensus, so making the censorship impossible. And because of the consensus algorithm, there is no problem of the corruption in the system, right? So everyone needs to agree on a particular validation, and then that transaction or that particular data will be saved on that Ethereum network. So that is the beauty of this Ethereum blockchain. After that, it is secure, so with no central point of failure, right? So it is secure, you can say, and all the data on a blockchain is cryptographically signed, so that if there is a problem of hacking happened, okay, if someone gets a piece of a blocks from the blockchain, and if he trying to encrypt or decrypt that block, he will not be able to do that, because the data on a blockchain is stored in a cryptography. So he will only see a number of digits and nothing else, right? So that is the best thing, that it is a secure. After that, immutability. So objects code can never be changed. So when you save your smart contract or some data on a blockchain, so it never gets changed by anyone, or it will never change. So that is the thing. After zero downtime, so your apps never go down, okay, or can never be switched off, because as you know, Ethereum network is a blockchain system. So if one node goes down, or if one node goes switched off, still there are other nodes, those have the same copy of that data that you can get from those nodes also. So this is the best thing also. After that, this is a truly global, so you can say the one computer for the entire planet that never goes off, right? So it is a truly global. After that, the ethers. So this is the main crypto fuel, okay, in which we need to pay for gas, okay, to save the data on Ethereum network. So this is the currency or cryptocurrency for the Ethereum network that we need to pay to save particular data. And after that, there is Ethereum wallet. So it's a gateway to decentralized application on Ethereum blockchain. So it holds the ether for the apps, okay. So these are some features that are superior, and those only present in Ethereum blockchain, okay, and these things are not present in a Bitcoin blockchain. That's why Ethereum blockchain is used all over the world for the development of a blockchain related applications, right? So as we see, smart contract. So what is actually a smart contract is, and what is the property and behavior of the smart contract? So smart contract is an account controlled by a code, okay, So in the next lectures, when we see that whenever we write down some code, okay, in a Solidity, and when we deploy that code on the Ethereum network, that time we get a particular digits, okay, or address for that particular smart contract, right? So whenever we deploy our smart contract on a network, we get address back, right? So it is a account controlled by code, right? So whenever you want to interact with the smart contract that you have deployed, you need that address, okay? So that is the thing. After that, a smart contract has a properties like it can have the code, it can store your data, it can store your balances, right? So these properties are also presented or is present in a smart contracts. After that, smart contracts can be deployed on a same network with multiple instances, or you can deploy on a multiple networks also. So there are some test networks present on Ethereum, like Ringkeeper test network, Kovan, Ropsten, and Ethereum, right? On those networks you can publish your smart contracts and communicate with your code, right? After that, when smart contracts deployed on any network, then we get a particular address, as I said just earlier, right? So what are the smart contract languages other than Solidity? So as we know, the Solidity is the main language for the Ethereum based blockchain thing, right? The smart Solidity is a contract oriented high level language whose syntax is similar to your JavaScript, and it is specifically designed for the Ethereum virtual machine, okay? But if you don't know about the Solidity language, and if you don't want to learn the Solidity language, then, and if you are familiar with the other languages like Serpent and Python, then also you can write the code in Python and Serpent, and you can publish your smart contracts and dApps on the Ethereum network. There is no problem, because these languages are also supported by the Solidity Ethereum network. And the upcoming smart contract languages are also coming, like Viper, Lisk, and Chain, okay? Those are upcoming smart contract languages that you can use in the future to write down your smart contracts. After that, what are the Ethereum clients? So as I told earlier, that Ethereum is a network having nodes, right? And we published our smart contract on that nodes, okay? But if you want to communicate with the Ethereum smart contract or that particular node, then you need a clients, okay? So there are multiple clients present right now in the world through which you can communicate with your smart contracts. So the clients are like Go Ethereum, MetaMask, Mist Browser, Parity, Ethereum Plus Plus, Ganache, and all those are the clients present through which you can communicate with your blockchain. After that, if you want to download the whole main net or the Ethereum blockchain onto your computer, you can use this get program, okay? That will download the whole blockchain data into your PC, and you can be a part of the Ethereum network also. So these are the some clients that you can use, okay? So this is all for this lecture. We will see the next things in the next lecture. Thanks for watching. Hello everyone. So today we are going to look at this topic, Solidity. So this is the programming language in which we are going to develop our smart contracts for Ethereum network. So Solidity is a programming language, as we discussed in our previous lectures, that Solidity is a high level language, and it can support almost all things, functions, and it is a very expressive language. So before diving into the practicals about smart contract coding or writing the code, we are going to look at some things of Solidity. So let's get started with the Solidity. So As seen in this image, here is the structure of a Solidity program. So it is the same like any Java file structure or JavaScript class. So here is the header file. After that, here is the contract. So it is just like a class in a Java, and the functions and other things is there. So Solidity is not a very different language from you can say Java or from JavaScript. It is similar to them, but the syntax is different a little bit. So it has a similarity, like it has a same class structure like Java or JavaScript. It supports functions, it supports imports, it has a control structure like if else. Also you can use loops like a for loop or a while loop. Also it supports some data types like uint, that is unsigned integer, boolean, array, struct, mappings, addresses. So these are the similarities which you can find in Java also or in JavaScript also. But there is some differences also, just like Solidity doesn't support float values. Okay, so this is the big difference. So you can't use a float value in a Solidity. The people who are developing Solidity language are working towards it. In the future, it might be possible that you can find a support for float values, but right now it doesn't support float values. Okay, also there is a similarity that you can inherit other functions or other contracts. So this is also possible in Solidity. Also there are some special structure like some modifiers or a modifier class that you can use in this Solidity language. So if you are going to write down some function in a Java or a JavaScript, that may look like the same in Solidity. So this is the Solidity function. So how you can write this? So this is a function. Okay, you have to put some function name here. Then this is the public view. So this is a function type, and it returns a string. So this is a return type, you can say. Then you can open the parenthesis here, and this is a returning some value to the caller function. So this is the same just like you do programming in Java or in JavaScript. There is no too much differences. There are some only basic differences or some additional access modifiers present in Solidity, like pure, payable. Okay, so pure keyword no one used. I haven't seen any smart contract that is used pure keyword, but many people use this payable keyword, okay, or this public, private, view and constant keywords. So we will see what is meant by public. So everyone knows that if you define any class or a method or a function as a public, then anyone can call this function. Okay, so in Solidity you can any other smart contract, okay, that also can call the function which is publicly described. Okay, so anyone call this function. After that there is a private, so only this contract call this function. Okay, so you whenever you write a private keyword before any function or contract, then that contract or a function becomes a private. So only that contract can access those things. After that, there is a view keyword. Okay, so this returns data but doesn't modify contract data. Okay, so as you see in this function, that this function is returning some value, some view. Okay, so you can use a view or a constant, both are the same, but just there is a keyword difference. Just many people use view, or many people can use constant also, but they do the same thing. After that, there is a payable keyword. So payable, uh, uh, we use payable whenever you want to whenever you want to access some ethers, or you want to get ethers to that function. So that time you use your payable keyword. Okay, so we are going to see all those things in our practical sessions, where we are going to use this payable private and public keywords. Okay, but right now we are just looking these things theoretically. Okay, then after that, how we can deploy our smart contract. So in earlier lectures, as we mentioned, that we can use different tools to deploy our smart contract on different networks, like Remix. Okay, after that, Test RPC, Geth, Ganache. Okay, so there are lots of different networks present. So on them we can deploy our smart contract. But how this smart contract actually compile and runs on the network? So whenever we write down a smart contract, then that smart contract will be compiled through any tool, and then we get two files after compilation of this smart contract. First is your bytecode, and second is ABI. So we get two files from our compiler, bytecode and ABI. And after that, we just deploy our bytecode on our networks. We don't deploy ABI. So what is ABI? So it is application binary interface, which we are going to use, or which people use to communicate with your bytecode, which is deployed on your networks. So whenever JavaScript code or a front end wants to interact with your smart contract, then you have to use that ABI file or ABI code to access the functions or contracts that are present in a bytecode. So what is actually a ABI looks like? So this is the structure of an ABI. So here you can see the structure. It is like a JSON. It's a JSON like structure. So this is a JSON file, you can say, and it contains all the information which you can use to interact with the smart contracts. Without ABI, you cannot communicate with the smart contract. So ABI is very important interface we will need in the future also to communicate with our smart contracts. So this is the ABI. After that, there is one more thing about the smart contract, that whenever you deploy your smart contract on any network, then please test it before deploying on some Ethereum network or on some test network, because whenever you deploy your smart contracts on those networks, you can't change them. That's why it's not possible to change any code or redeploy at the same address. So that is not possible in Ethereum blockchain. So please test your application and do proper programming before deployment. So I will say test properly before deployment. So these are some points that you need to remember before diving into the writing of code. So these are some points. So please take care of these points and in the next lecture. Now we are going to dive into our smart contract things with the remix. So thanks for watching. Hello everyone. So in this lecture we are going to see about the information regarding ERC20 token, because in our exchange we are going to use this ERC20 fungible token for our exchange. So for that and for the more information you can Google it. Okay, so I'm going to Google it for the ERC20 token, and here you'll find some of the information. And if you go to this website, that is the Ethereum wiki. Okay, this is an official site for ERC20 standard token. So this is the very famous and the first very popular token in the world, on which many of the ICOs and exchanges are actually built upon. So this is the very famous token. So, and this is the page where you will find the updated information and other things on this page. Okay, so let me explain you step by step what is ERC20 token is all about. Okay, so ERC20 token is an Ethereum standard protocol for token generation. Okay, in ERC20 what you can do is that you can make virtual tokens of a same type. Okay, means every token is not a different one, every token is the same. Okay, it's just like your $10 bill. Okay, like if you go to anywhere in the US, and if you find a $10 bill has the same value everywhere in the US, right? So its value is the same. So every $10 bill is its value is equal to $10 everywhere in the US, right? So those are all same bills, right? Same here for the ERC20 token also. If we generate some tokens using this standard format ERC20, then you will have the same type of token of the same shape, you can say, of the same value, of the same thing, of same properties, same characteristics. Okay, and they have the same value throughout the standard, right? So this is the main functionality of this ERC20 token standard, right? So how we can build any token supply, or how we can generate or mint a token from this ERC20, right? So for that here you will find a standard interface here. So this is the main interface that actually gives us the functionality that we require for our token generation. So here you will find the functions, events and contracts, like. Okay, so in these functions and these events you can use to generate your own tokens using this ERC20, right? So here you will find that your every token must have some name. Okay, just for example, they have given the name that is token name. Okay, and every token should have a symbol. So whatever may be the symbol that you want to give, you can give it here. Okay, and after this is the decimal. So here is the decimal, that is 18 is the most common number of decimal places. So these are the things that actually already this ERC20 standard token provides to us for the generation. Okay, so let me show you how actually this contract works. Okay, so if we go to this here things here, the contract token fragment. Okay, here we will find some mappings and balances of and transfer functions. Okay, so you can copy this contract from here also, and you can run this contract into Remix and check out the things how this function actually works. So let me explain it for you. So if you go to this page in the below section, there you will find an example. Okay, so here they have given an example of this ERC20 standard token contract. Okay, so here they have given us two account, that is, this is your first account and this is your second account. Okay, this is the address for the first account and this is the address for second account. So first account has the balance of 100 tokens, you can say, and second account have the balance of 200 tokens. Okay, and now if you want to check the balances of these accounts using this interface, then what you can do is that you can call this function, that is the balances of function, and you can pass the address of the token owner. Okay, and that will returns you the balance. Okay, so this function you will find it here. They have written down the code for this. Okay, so here you will find the function balances of, you need to pass the owner's address, and in returns you will get the balance of that particular owner. So here what they have shown us, that you can call this balance of function using the contract instance. So this is the contract instance by using which I am calling this balance of function for this particular address, and it will return me 100 tokens, and for the second address it will return me 200 tokens. Okay, so how this is how actually this balance of functions work. Okay, after that, if you want to transfer some tokens from account 1 to account 2, okay, here also they have given us an example for this transfer function. Okay, so if account 1 wants to transfer 10 tokens to account 2, okay, then how this contract will actually going to work, and what is the code for that we need to write down for this, right? So for that, what we have to do is that we have to call this transfer function. Okay, so this is the transfer function here. So here you will find that it is taking the address of a 2, okay, the address to which you want to send the tokens and the number of tokens that you want to send to that particular address, and this will returns a boolean value to you as a success or not. Okay, and this is the function they have written for this transfer. So this is the function for this transfer thing that you will find it here. So whenever you call this function, transfer function, what happen is that this is the code. So I am transferring to this account 10 tokens. Okay, so after the transfer becomes successful, you can go and check the balances of this particular addresses again, and you will find that, okay, so address 1 should have the balance of 90, and address 2 should have balance of 210, because 10 tokens we have transferred from account 1 to account 2 using this transfer function, right? And for that you can use, for checking the balance, you can use this balance of function. Okay, and after that, here you will find some other things like approve and transfer from token. Okay, so here is an example for approve. Okay, so if your account 1 wants to authorize accounts 2 to transfer some tokens to account 2, okay, right? So that time account 1 will execute this function, that is approve functions, right? So how this approve function will work? So here account 1 will execute this approve function by using the address to which it is approving that how much tokens account 2 can spend in the name of account 1. So account 1 is allowing account 2 to spend 30 tokens in the name of account 1. Okay, right? So this is the thing. So now account what actually account 2 can do is that account 2 can spend up to 30 tokens in the name of account 1, and that is this approve function is all about. Okay, and after that there is a function that is called and transfer from function. Okay, so here is an example for this transfer from function. So if account 2 wants to later transfer some tokens from account 1 to itself, okay, so that time it executes this transfer function. So here you will find this is the function that we have called it, they have called it here. So this is the address of account 1, this is the address of account 2, and this is the number of tokens that address 2 wants to transfer later, okay, to itself from account 1, right? So those 20 tokens will be transferred from account 1 to account 2 by account 2, because this contract is called by this account 2, right? And that's that time you can use this transfer from function, and after that you can check the balances of all those things, okay, right? And this is also a sample. Here they have given the whole sample for this ERC20 token up here. Okay, you can check out this sample in a remix. So this is sample has all the functions here. They have given us a sample, so you can go and copy and paste this sample into the remix and you can check it for yourself. So this is all about the Ethereum ERC20 token standard and how this is the function and this is the contract for this. Okay, so in our exchange also we are going to use this ERC20 interface for our tokens. So we will meet in the next lecture and we will see the next topic. Thanks for watching. So hello everyone. So in this lecture what we are going to do is that we are going to check this ERC20 smart contracts example in a remix. So you will get an idea of the remix also and how to run the your smart contracts into remix. And for that what we are going to do is that we are going to copy this sample token supply, okay, and we are going to paste this sample token supply with some functions. Okay, some functions we are not going to check. Okay, like this, there are some unwanted functions now added in this smart contract, so we are not going to test them. Okay, just like this, transfer any ERC20 tokens and approve and call these things. So I have already copied this smart contract into my notepad. So now let me go to the remix, and for the remix you have to go to this website, that is remix.ethereum.org, and from here you can do the testing for your Solidity smart contracts. So what you can do is that here you will find all the things. So this is the browser based ID, right? So okay, so first of all let me show you the some slides regarding the remix, their features and what are the things that actually the remix provides. So let me go through that first. Okay, so what is actually remix ID is it's a browser based ID in a cloud. Okay, and remix ID is used for smart contract development. It is the best tool you can have to write down your smart contracts before writing down in some other softwares, because remix has some very good features, like it has an integrated debugger, integrated testing environment, it has a static analysis, and it can also deploy your contracts on some testing networks also. And what is the good part of remix is that It also works with the MetaMask or Mist. If you don't know about the MetaMask or Mist, then don't worry about that. In the upcoming lectures, I will show you what is a MetaMask or a Mist. Okay, and if you want to check out the site, you can go to this link, that is remix.ethereum.org. Okay, so now we are come back from our remix slides. So now we are going to test that fixed token supply sample code in this remix solidity browser based IDE. Okay, so I have already copied that code into my notepad. So the same code I am going to paste. So this is the pre-generated code that I need to remove this. So just select and remove and paste your code here. Okay, so now I have already pasted the code here, and here you'll find all those things, like you can compile this Solidity smart contract, okay, from this panel. Okay, and you can run, you can analyze the things, you can test, you can debug, and all the things you can do with your smart contracts. You does not need any other software to check out your smart contract. This is the best thing actually this Ethereum company has provided to us. This is that is the remix. Okay, so for now we are going to test this fixed token supply contract. So let me compile this first. So you can go here and you can click on this start compile button. So now it is compiled and it is showing me some warnings. So these are just warnings. Okay, it is like here it is giving me like error warning that invoking events without emit prefix is deprecated. Means that some of the things now has an updated in this remix browser compiler also. That's why it is showing me that some of the things that are deprecated. So you can do is that you can emit those functions and you can use that function as it is. So just for that they are giving me an error for this transfer message. Okay, so I'm going to write down emit for that. After that, same for approval. So find the approval function. So this is an approval. So again save this. Okay, and start the compilation again. Okay, and these are some other things that I need to check out. There may be some other transfer function. Okay, but these things doesn't matter to us actually. Okay, but in this code here you'll find that this is the fixed supply token contract example thing. Okay, and they have given the symbol for this token as a fixed and the name of this token is the example fixed supply token. Okay, and the total supply is around 10 million here, and other code and other functions here. So now let me show you how actually we run this code in this remix. So just go to this run tab, and here we'll find the environment. Like this is the environment. Okay, so this is the JavaScript virtual machine which is already presented here. This is the injected web3. So whenever you want to work with the MetaMask, that time you can use this injected web3, and this is the web3 provider. So whenever you have any script that you want to run from the code, that time you can use the web3 provider. Okay, so for our example I'm going to use this local JavaScript virtual machine for our testing. So this is the JavaScript virtual machine, and these are the 5 accounts here with 100 ether each. So these are the 5 dummy accounts which are pre-loaded with 100 ethers each. So we can use those ethers for this for the gas supply. and we can generate the tokens from this, right? And we can transfer the tokens between these accounts also. And this is the default gas limit they have already given. So, and this is the value. If your function has some payable keyword, means that whenever you call that function, and if that function is a payable, you need to transfer some ethers or some value, okay, by using this. So you can pass the value using this, but in our function there is no payable functions written, and so for that I am not going to pass any value. And after that, here you can see the token interfaces and the contract. So first, this is my first contract, that is ERC20 interface, and this is my second contract, that is a fixed supply token. Okay, that's why it is showing me two contracts here. Okay, so first is only interface, so we cannot deploy this interface because the interface does not have any functions. Okay, so all the functions are written down in this fixed supply token, right? So here you will find all the functions are written down in this fixed supply token contract. So we need to deploy this fixed supply token. So I am going to click on this, and after that I need to click on this deploy button. Then okay, so here you find that my fixed supply token contract now has been deployed on this JavaScript virtual machines and at account 1. Okay, here you will see my account is now deducted with some ethers, because those ethers actually taken by this remix ID to run this and to deploy this smart contract on this JavaScript virtual machine. Okay, that is the amount of gas they need, and they have deducted from the ether. Okay, and now this is the memory address at which it is now deployed. Okay, so as we have said that whenever you deploy a smart contract on some blockchain or some Ethereum's virtual machine or something like that, you will get an address for that particular smart contract. So this is the same thing here. So at this address it is actually deployed, and if you pull this up, here you will find the details. Okay, so here this is the green thing, means that our function is actually executed successfully. And for the more details, you can open this thing and you can see how much gas, transaction gas it cost us. Okay, and all the things. So this is the console where we will get the results, like if it is a succeeded or not, what are the problems and everything, and from here you can debug also. Okay, so but right now we don't faced any problems. Okay, so now we are going to check all these things. So we will start with this total supply. So our total supply that we have mentioned here is that around 10 million. So when I click on this button, I should get the 10 million total supply of the tokens. Okay, so let me click on this. Okay, so it is, this operation is also successful, and here you'll find that my token fixed supply token contract has a 10 million token supply. Okay, and after that I can also check the symbol. So this is the symbol, that is a fixed. After that I can check the owner's address. Okay, so owner's address will be this address, that is a 0x692, that it should show me, because the owners of this contract is this address. Okay, so sorry, not this thing, this is the address, this is the address on which it is actually deployed, and this is the owner's address. Sorry for that. So 0xCA3, so this is the owner's address from which it is deployed. Okay, and after that the name, so example fixed supply token, so this is the same here. After that the decimals it will show is 0, right? And if we need to check the balance of the first owner, okay, what we can go do is that we can copy the first address. Okay, so this is the copy, and we can paste it up here, and we can check the balance of things, and here you'll find 10 million tokens actually this account holds. And if we go to the second address, you can check for the second address, copy this, and so I think it should return as the 0 because account 2 doesn't have any tokens, right? Because so it is showing me the balance of for account 2 is a 0. So after that, what we can do is that we can transfer some tokens from account 1 to account 2. So for that we need the address of account 2. So this is the account 2 address that I need to copy, then I need to paste up here, and I need to pass the number of tokens. If I am going to pass like 500 tokens, just click me on this transfer. Okay, my operation is successful now. Okay, and if I go to account 2 now, and if I check the balance of account 2, I think it should show me, sorry, I need to check with this. So now this is the transfer function that you can check it here. Okay, so you need to pass the address of the account 2. So you can copy here, you can paste it here, and you can pass like 500 tokens, and it will show you the success. Okay, so this is how you can test all these functions and all other things in this fixed supply token smart contract. Okay, so this is just an example that they have given us, so you can go and you can check all those functions by yourself. Okay, they have already given the explanation for each and every line of code and things. Okay, so you can use this token supply example to learn more from this thing. Okay, so this is it for the remix. So in the next lecture we will start with our exchange, and thanks for watching. Hello everyone. So in this lecture we are going to see and the definition about an exchange, what is an exchange is all about, okay, and why it is called an exchange. Okay, so let's get started with an exchange. So what is an exchange? So according to the Wikipedia and according to the definition, an exchange is an act of giving. In the other's perspective, you can say you can trade the currency like one US dollars for you can have another currency like euros. Okay, so at an exchange, in a general example, there are some forex trading exchange where you can put some type of currency like US dollar, and if you want in return some other currency, they will give back that currency to you of that same value. Okay, so so these are the exchanges where you can give things and get things. Okay, but in a cryptocurrency exchange, what we can do is that we can exchange. So you can trade tokens to token with tokens, or ethers with tokens, or anything. Okay, so things are like that in the exchanges. So what is the important thing in the exchange? In the exchange, the important thing is the demand and supply thing, right? Because in the exchange, and why exchanges actually run is because of this demand and supply things, right? Because some people do some offers and they wanted some things back from that exchange. Okay, so that time the exchange comes and they uh, see those criteria and uh, s- uh, see that how we can give these people what they actually wanted. Okay, for an example, in this here I am write down an example here. Okay, so there are two peoples like Sam and Adam. Okay, and Sam says to the Adam that okay, I want to buy 10 ethers. Okay, and I could offer you $100 for each ether. Okay, so Sam is telling the Adam that I want to buy 10 ethers from you. Okay, and I am ready to pay $100 for each ether. Okay, means that for 10 ethers he is willing to pay $1,000, right? But what Adam says to Sam that okay, I have that ethers. Okay, but I want a higher price, that is a $120 for each ether. Okay, so here the Adam is asking for more value. Okay, so that's why in the exchange you can see the demand is $100 for each ether. Okay, and supply is there. Okay, but its value is $120 each. Okay, so you can do the spread between these, so that is a $20. Okay, so these are the scenarios that occurs in the exchange. Okay, so how these scenarios are we are going to tackle down, and how actually these crypto exchanges tackle down these things. Okay, so these things are tackled down using this market orders and limit orders. Okay, so we will see what is a limit orders first. Okay, so as you can see in this example that Sam wanted 10 ethers for $100 each, and but Adams don't want to sell his ethers at the price of $100 each. Okay, he's asking for more. Okay, so at that time, here you can see this is the thing that Adam is selling 10 ethers for 120, and Sam wants to buy 10 ether for 100 and each. Okay, so this is the bottleneck that is created here. Okay, so there is no another seller or buyer here who are paying for the same price, and the things will be traded. Okay, so here only two persons are there in the exchange. Okay, so because there is a bottleneck happened in right now in this case, because there is no match between their demand and supply, right? Between their prices, right? So these uh, things will be stored in the exchange as a limit orders. Okay, and those will be executed later. Okay, when some market makers will come, like there are some people comes like Joey and other people, any person came, and he also says that okay, I have also 10 ethers and I want to sell those 10 ethers for $100 each. Okay, that time Sam can able to buy 10 ethers for $100 each, because there is a buyer present in the exchange. Okay, and now the seller came to the exchange and he's selling at the same price, okay, that Sam wanted to buy. Okay, so that order will be executed, and that order is called a market order also. Okay, but in our example, say Sam says okay, I urgently need 5 ethers. Okay, and he's saying to Adam, whatever may be the rate you wanted, I am willing to pay that rate to you, but I want 5 ethers each very urgently. Okay, so that time Sam is willing to pay $120 for each ether. Now what the exchange will do is that it will transfer 5 ethers, okay, to the Sam from the Adam's account, and it will pay $120 to the Adam, okay, into his account. Okay, so this things is directly going to execute or run, because there is a condition that is you can say doable by the exchange, because now he only wants a 5 ethers and Adams has a 10 ethers and he's asking for $120 each, right? And now but the Sam says, I don't have that amount of budget, I can buy 5 ethers for $120. So exchange will see that, okay, so um, I can run this trade between Sam and Adam, because the condition I can fulfill, I can pass 10 ether from Adam's account to the Sam's account, and I will pay and Sam will pay $120 for those five ethers, right? So that is called the market orders, and market orders will be executed immediately, and those the market orders never halt. Okay, so whenever there may be the condition that is appropriate and that exchange can fulfill immediately, those things or those orders we can call as a market order. Okay, and those orders, those are not executed right now, because those there are no conditions appropriate for the exchange to run those buy and sell things. Okay, so those orders will be placed into that limit orders, and that is called the limit orders book and the market orders book. Okay, so this is how actually this exchange things actually works in a cryptocurrency or in the real world also. Okay, so we will see its next part in the next lecture. Thanks for watching. Hello friends, so in this lecture we are going to see the interfaces that we are going to use in this exchange contract. So for that I have written down some of the functions that we are going to write down in our original smart contract for this exchange. Okay, so let's get started with these functions and their workings. So first is the add token. So we are going to use this add token. So this function will has two parameters, so we will pass two parameters, that is the symbol name first, and the second is the address of the ERC20 token address. Okay, and the only owner can evoke this function, means that only owner can add the tokens to this contract. Okay, so what this function will do is that it will add the tokens with the particular symbol name into the exchange. Okay, so this is the token management actually for a specific address, and the second one is the has token function that we are going to write. So has a token function will take a parameter as a symbol name. Okay, and it will return boolean value. Okay, so it will return a true or false value. Okay, so means that this token can be traded or not. So this has token function will return us this result. After that we are going to see the deposit token function. So as the name suggests, so this is the funds management stuff that we are going to look into the exchange when we write down them. So in the deposit token we will pass the symbol name and the amount of tokens that we want to deposit. So what this deposit function will do is that this will deposit the tokens. Okay, so it will deposit the particular tokens for that exchange contract and for that particular symbol name with the particular amount of tokens. Okay, so this will just send the tokens to that contract exchange. Okay, so we will see this function in the detail when we write down this functionality in the smart contract. Okay, after that there is a withdraw token function also that we are going to write in the future. So this withdraw token function will have these input parameter as a symbol name and the amount of tokens. Okay, and so as the name suggests, this function we will use to withdraw some tokens from the exchange. Okay, so whenever we withdraw some tokens, so those tokens will be directly sent to a specific addresses. Okay, if there is a if there is an enough balance there, then we can withdraw the token. Okay, after that there is a get balance function that we are going to write. So get balance function will take as take input as a symbol name parameter, and it will returns as the token balance for the address that calls. Okay, and after that we can also do funds management for ether, right? Because these three functions are related to the tokens. And now we can also deposit the ether and withdraw the ether. So first method is the deposit ether, that I'm going to mark as a payable in the smart contracts. So payable is the keyword which sorry, is a spelling mistake here. So payable is the keyword that that we use whenever we want to send some ether to that particular function. So that time we use this payable function. So whenever I have to input some ethers into this exchange, that time I can call this function with this payable parameter, and I will send some ethers along with the call, and those ethers will be submitted to that exchange. So this function will be used for that. Okay, after that there is another function, that is your withdraw ether function. So it will take amount in V. Okay, so V is a unit like ether, so it is like in general perspective it is like cents. Okay, for dollars. So it is a V for ether, so it is a smaller version for the ether. So in our exchange we are going to withdraw ether in V unit. Okay, not in ether like 0.1 ether, or not like 0.2 ether. We will like 1000 V or 2000 V, 5000 V, whatever may be the amount, but that we will withdraw in a V. Okay, so the benefit of the V is that we can withdraw a smaller amount of funds also from the exchange. So that is the benefit of this. Okay, after that we will also get the balance function here. Okay, so this will return the current balance of an ether. It is a simple function. After that there are place orders things like buy token, sell tokens things. Okay, so as you can see here, the buy tokens function will have three parameters as an input. First is the token, second is the price in V, and the amount of token to be buyed. Okay, so this function will try to buy an amount of tokens for a particular price in V. Okay, so if there is a order which is okay, like for example which is like one token is like for $100. Okay, and if another buyer comes and he is also offer the same amount of things, so that order will be executed here. Okay, the if ask price is less than the price in V, then this will be executed. Okay, like market order. Okay, and if that condition doesn't find in any of the market order list or in general list, okay, that order will be saved as a limit order. Okay, and the same is for like sell tokens. So sell token also take three parameters for as an input, and this will also tries to sell the amount of token for a particular price. Okay, and it is same, and if the bid price is greater than the price in a V or price in ether, then the order will be executed, or else it will be marked as a limit order, right? And after that there is a order management for this also, because sometimes order needs to be cancelled. Okay, so that time we can use this cancel order function. Okay, so this will take four parameters like symbol name. Okay, the boolean value is seller is sell order. Okay, price in V and offer key. Okay, and this will just cancel the order. Okay, for calling from particular address with that symbol name for that particular specific price. It will just cancel that order. Okay, after that there is a get sell order book and get buy order book also. Okay, so get sell order book will returns us the lowest to highest price. Okay, so this will aggregate all these prices. Okay, and it will aggregated by the price, and it will returns us the lowest to highest price order sell order book. Okay, and just like the same way the get buy order book also returns the same as a sell order book. Okay, from lowest to sorry here it from highest to lowest. So in the buy book it came it's reverse. Okay, so it will return lowest to highest to lowest prices, and in the sell order book it will return you the lowest to highest price. Okay, so these are the functions that we are going to integrate in our smart contract in the upcoming lectures. So this is just an overview for this key functions that we are going to use. Okay, so we will meet in the next lecture, and we will try to implement other things, or we will see what else we need for this exchange. Okay, thanks for watching. Hello friends, so in today's lecture we are going to see this buy order and order book. Okay, so how actually this buy order sell orders book works in the exchange. Okay, what is the logic behind them. Okay, that we are going to see here. Okay, so for example I have written one example here. Okay, so this is the buy order. Okay, this is the bid. Okay, the user one comes to the exchange and he wants to buy 100 fixed token for $10 each. Okay, so his entries look like this in our order book. It's like $100 100 tokens at $10 he's asking, or he wants. Okay, and another user 2 wants to buy 50 fixed tokens for $12 each. Okay, so his entry will look like this. So 50 tokens at $12, so he is willing to pay a higher price for each token. Okay, so now there is no one in the exchange who is selling 100 fixed token at $10 and 50 tokens at $12. So these two entries will be inserted or saved into our order book. Okay, so there will be these two orders that will be saved in this order book. Okay, and after that, if some sellers come to the exchange, okay, those wants to sell their tokens. Okay, so if first seller comes and he offers that I have a 10 tokens and I want $10 for each token, so he will sell his token in this pattern. Okay, so he is asking 10 token for at $10 each. Okay, and at the same time there is another user comes, the seller comes, and he said that my offer is $10 10 tokens at $12 each. Okay, so the 10 token at $12 each order will be executed at $12. so some partial order will be executed. Okay, in this, so the order will be order book will be now has this status. So user wants the same thing, 100 tokens at $10 each, and user 2 now has a 10 dollar in his wallet. Okay, but he is also he still have this order that is a 40 at 12, because he got 10 from the earlier seller. Okay, so now the order book status is right now this. Okay, and after that, again what happened is that now again the another seller comes and said that I want to sell 100 tokens at a $10. Okay, and if I check to the my status of the order book, I have the order of 100 tokens at $10 and 40 tokens at $12. Okay, so what will exchange do is that, okay, so exchange will do is that it will execute this book order first. Okay, and this is the 40 tokens at $12, because exchange also exchange always wants to sell at a higher price, because they also get benefited from that. Okay, so it will uh, sell those 40 tokens at $12 first, and after that it will execute remaining 60 tokens at $10 each from that order book. Okay, now our order book only will only contain $40 at $10 each, 40 tokens at $10 each, because now this entry is fulfilled. Okay, and from this entry we have sell buy our 60 tokens. That's why only 40 tokens are remaining. So our book our order book will contain only this 40 at $10 each. Okay, so now let me show you how actually the partial order works also. So if there is a bid like for 40 tokens at $10, and if another seller comes and he said that, okay, I want 50, I have 50 tokens and I want to sell that for at $9 each. Okay, that time what will happen is that this 40 at 10 will be executed. Okay, by the exchange because of the price, and we have this earlier book order book there, right? And now the new entry will be entered into the order book, that is asking rate, that is 10 tokens at $9. So this is how actually this order books, partial orders and other things work in exchange. So every crypto exchange, this is the pattern that you will see in every exchange, crypto exchange. Okay, so this is just little bit of an idea of how exchange actually works, and how our exchange will also going to work. So we will see the next part of this in the next lecture. Thanks for watching. Hello everyone. So today we are going to look at some theoretical lecture about what are the types of variable that can be supported by the Solidity, because we need to understand this variable section and the coding structures that has been supported by this Solidity language. So before deep dive into this lecture, I'm going to install a visual code into my system, and that software we are going to use for our development purpose. So let's get started and find the visual code. You can go to this Visual Studio Code website here. So website is open. Here you will find a button, download for Windows. So whatever may be your operating system, go and download this stable version. So my operating system is a Windows x64 based. So I'm going to install this software into my system. So go and install this stable version. So first let me download this. So now it is downloading here. Okay, so it is now downloaded on my desktop. So go to desktop and do the setup of this Visual Code. So now it is doing its setup. So just wait for a while. Just click on this launch Visual Code and finish it. So it is a free software that you can use as your editor to code the Solidity programs and smart contracts. So now it is opening here. It will just take some time for the first time. Okay, so actually this Visual Studio Code actually made for the Microsoft C hash codes and something like that, but it can support the languages like here you can see a JavaScript, TypeScript, Python, PHP, Azure, Docker and more. So for those language highlighting, you can use their extensions. So now we are going to use this Solidity language in this Visual Code, so we can go and install their extension from their store. So you can find the store extensions. So click on this extensions here, and here you'll find the top extensions that you can install into this Visual Studio Code editor. Okay, so like Python, C, C++ and other languages, but we are interested in Solidity, so find the extension for Solidity. So here is the first Solidity version that you can install. Just click on this install button. Now here you can see it is showing me that it is installing into my Visual Studio Code editor. So actually if you even doesn't install this extension into your this Visual Studio Code, then there is no problem actually. But why I am actually installing this software? Because it highlights the syntax, the correct syntax for the Solidity. Just like here you can see that the syntax highlighting, snippets, okay, compilation of the current contract. So this can be possible with this Solidity extension here. So this will help you to understand the highlighting of the Solidity program, their contracts and other things. So if you wish to install this, you can go and install this extension into your Visual Studio Code, or you can use any other editor for this. It sometimes takes some time because it's a little bit huge extension. That is why it is taking some time, I think so. Okay, but it is taking okay. So now it is done with the extension. So just close this. Okay, so as we discussed earlier in this thing, that we are going to look at the types of variables supported by this Solidity language. So what we can do is that we can go to the file, new file. Just I am typing that. I am not writing down any Solidity code here. Okay, I am just showing you what are the types supported by the Solidity language. So the strings, as you know, the variable type supported by solidity. Let me zoom this. So first is a string. Everyone knows that string, like hi, hello. So these are the string which is supported by Java and other programming languages. So Solidity also supports a string type of variables. After that, it also supports a boolean like true and false values. After that, it also supports integer, like as we know, 0, minus 100 and 100 and plus value like 100. It has a new you can say variable that is very important and that is widely used in Solidity, that is called unsigned integer, that is uint. This is unsigned integer. So it has only positive values, it supports only positive values, means that you have only 0 and 100, but you cannot have minus 100 here values, only positive value it supports, positive values it supports. Okay, so after that, float is not supported by the Solidity. Okay, and there is also a new variable called address, so which gives you the address of the owners and senders and everything in the format like 0x8465367 something like this. Okay, so these are the some variable types that it's supported by the Solidity language. Okay, so if we go into the deep about this, like integer and uint, their ranges, so let me give you some details about those. Okay, so what is the main difference between this integer and uinteger range? So many of the people you know that integer starts with integer value like 8, after that integer 16 is there, after that integer 32 is there, and so on, and last value is the integer 256. Okay, and as you know, integer 8 only supports up to minus 128 to upper value is 127, and integer 16 supports from minus 32,768 to upper value plus 32,768. Okay, so just like that, the number goes on increasing at both the end, at the negative end also and at the positive end also. Okay, like into 56, integer 256 supports really big number, big negative number, you can say negative number, and at a plus side, upper side, it is a really big positive number. So this is the main difference between the integer 8 and integer 256, that their range is different. Okay, so actually many of you use only integer, you never use like integer 8 and integer 256. So integer is as same like integer 256, both are the same. So in many examples in Solidity also you can find integer or integer 256. Okay, so both are the same, there is no difference between this. Okay, but as we discussed that there is a uint, that is unsigned integer, okay, that is also supported by the Solidity. So it has also, it starts with uint 8. Its lower value is 0 always, and upper value is 255. And uint 16, its lower value is also 0, and upper value is 65,535. okay, and just like the same way in integer, it supports uint 256, and its initial value is also 0, but positive value is really big positive number. So uint only supports a positive number, it doesn't support any negative number. So in Solidity, many of the people uses this uint 256. So in our program also we are going to use this uint 256, or you can use uint sorry, I have some spelling mistake here. So uint, and so uint, and that is same as uint 256. So it is also the same, that is u integer is equal to u integer 256. So you can use any of these things. Okay, so as we have seen that in this lecture that it supports many different types of variable like string, boolean, integer, uint, and addresses. Okay, and we have gone some in details for the integer and what is the uint. Okay, so it is just a variable supporting video, actually what the variable it supports. So in the next lecture we are going to see another things that it's supported by the Solidity, like mappings and struct, and what is the message variable. Okay, so that we are going to see in the next lecture. Thanks for watching. Hello everyone. So today we are continuing our last lecture. In last lecture we have seen that what are the variable types supported by Solidity. So in this section I am going to show you what are the structures and what are the new types of things that is supported by this Solidity. So first I will show you the message variable. Okay, so you can say it is a global variable. So what is a message variable in a Solidity is that it has the address of the contract. Okay, you can have this message variable accessible wherever you wanted in the code. So this is a global variable by default, so you can call this message variable in any function or in any constructor. Okay, so this gives you the address of the owner who is either sending the money or sending the ether, or the address of the contract. So you will see this message variable many of the times in Solidity language. So always remember that this variable is a global variable and that can be accessed anywhere in the program. So this is the by default variable that has been given by the Solidity to us that we can use in our programs. So another things that Solidity gave us is a mapping. So mapping is a collection of key value pairs. It is just a collection of key value pairs. Okay, all the keys in a mappings must have of the same type. Okay, just like for example mapping. So this is the syntax for mapping. string, okay, or mapping, integer and boolean. So it is a collection of key value pairs. Okay, many of people know that this is also used in other languages, but their name is or syntax is different. Okay, so in Java, like, you can say it is a hash. Okay, in Python you can call it as a dictionaries. Okay, something like that. Okay, but in Solidity we are going to call it as a mapping. Okay, so it is a collection of key value pairs, and as I said, all keys must be of the same time and all values must be of the same time. Okay, so this is the mapping. And if you want to use a collection of a key value pairs that has a different types of values or keys, then you can go for the struct. Okay, so it is a collection of a key value pairs that can have different types. Okay, for example, let me give an example. Okay, first write down it's also a collection of key value pair but of different types. So for example, you can have a struct car, and in that you can have a string make string model and event value. So as you can see here that it is a structure of a different key value pairs. So here you can use a string, okay, and you can also use event or boolean or any other variable type. Okay, so it will give you the different types of structure that you can use as a variable in your program. So this is another things that is given by this Solidity. So in our program also we are going to use this struct thing and the mappings thing and message also. So this is it for this lecture. So we are going to see the program in the next lecture. Thanks for watching. Hello everyone. So in the today's lecture we are going to install the essential softwares for our smart contract development and for our project. Okay, first of all we need to install the Node.js. Okay, so you can go to the google.com and find Node.js. In that google.com, go to this website, that is nodejs.org, and here you will find different version for different operating systems. Okay, but I have a Windows 10 operating system which is a 64-bit, and for that I am not going to go with the current version, that is because it's a current and unstable version right now. So they have recommended 8.12.0 version, that is the latest one, and this is the stable version that you can download for your software. Okay, so just click on this and it will get downloaded here, and after that click on this and do the setup. Okay, so it is now doing the setup here. It will take some time depending on your PC's hardware configuration. Okay, so it is, yeah. So wait for some time to complete this setup. Okay, and after the setup has been done, okay, just click on this finish, and you can now then go to your command prompt and open that command prompt in administrator mode, just like this, run as administrator, and you can check the node version by using this command, that is node minus or -v. Okay, so this is the version that I have installed here. After that, I need to install truffle also. Okay, so for truffle, what you can do is that you can write down this command in your command prompt, that is npm. Okay, this is a node package manager which help you to install the other softwares. So npm install -g -g truffle. So it will get downloaded and will be installed on your system. And you can also check the truffle version using truffle version command. Okay, here you will find that you have this truffle version of 4.1.14 and the solidity version of 0.4.24. okay, that is the latest one on the solidity. Okay, so now we have installed the node JS library and this truffle software. Now we need to install the Ganache. Okay, that is our test network for offline testing, and for that we need to go to the truffle website. So just go to the google.com again and find truffle framework, and this is the website. Just click on that and go here, and here you will find a Ganache. So just click on this GitHub repo here. So there are two versions. One is a command line version and second is the desktop version that has an UI. Okay, so this is the UI version, and another is the CLI version. Okay, you can go here and click on this Ganache. Okay, and okay, so now just go here and click here, that is need another OS download, and here you will find this version here, different versions, but I am going to go with this version, that is the exe file for Windows. So now it will get downloaded here. So wait for some seconds to download it. Okay, and click on this to do the setup here. just install this. And click on this finish button. So now my Ganache will run automatically after this. So now here it is open. So just disable this, analytics enabled. So disable this and click on this continue, and this is the graphical version of the Ganache. And here you will find some accounts with the balance of Ether. Okay, there are blocks, transaction here you can see. So this is the just test local test network which we will use for our testing of the smart contracts. Okay, so you can go and download all these softwares from the net as per this video and install it before we can start with the smart contracts coding. So we will meet in the next lecture. Thanks for watching. Hi everyone. So today we are going to look at our project. So we are starting with our project. So we have to write down some smart contracts in a truffle. So in last lecture we have installed a truffle. So now we have to start with our project directory, and we are going to check how to create the files for our smart contracts and how to use truffle. So let's get started with command prompt. So I am opening a command prompt here. Okay, so now what we have to do is that we have to make one directory there. So go to your particular drive, cd any drive. Okay, I am going to the core of my drive by using cd dot dot. Now I am going to make a directory here. Token. So here you will find a token directory is now been created. Now I have to go to this directory by using this command cd token, and now I am in the token folder. Here I have to initialize my truffle project here. So the command for initialization of the truffle is like this: truffle init. So just run this command. So whenever you run this command, it download and unpacks some folders. Okay, so it will give you the project structure, project files that you can use for your project. So now we are going to open those files, but for those files you need some editor to open those files and to write the code in those files. So now we will go to some editor. I am going to use a Visual Code in this project. So go to google.com and find Visual Code. You can use any other editors also, but I prefer this because it's an easy. So you go to this link and you can download this stable version. Okay, my PC is Windows 64, that's why I am using this. Okay, so I am already downloaded and installed this Visual Code in my PC. So I am not going to again install this software. So now just I am going to open this software and I will show you the folder structure. Okay, so now I open this Visual Studio Code software. So this is the interface for this. Okay, so now what I have to do is that I have to open this folder that we have just created in a C drive. Okay, this is a token folder that we have created using the command prompt here. Okay, so just open this, select a folder, and here you will find that your project is opened here. So there are some folders which was created in the command prompt automatically by using this command, so you does not need to make these folders manually. So we are going to look at these folders, like what is the contracts, migrations and test. Okay, so this contract folder is where we are going to keep our Solidity files or write down our smart contract codes. So this folder we are going to use for our smart contracts. Okay, after that there is a migration folder which is used to deploy our smart contract script that can be used to deploy our smart contracts on particular networks. Okay, after that there is a test folder that can be used to test out our smart contract code. In this folder we have to make some test files and run that test files to check whether our contracts are okay or not. After that there is a truffle config file and there is a truffle.js file. So this file contains the network code on which you want to deploy your smart contract. If we want to read more information about the structures and files, then you can go to the Truffle website. So that is a Truffle framework here, and you can go to the docs, and in that to just click on this Truffle, and here you will find creating a project with the Truffle. So as I just mentioned the steps in this video, those steps you will find here also. So just like make some directory, then go to that directory and use this command, truffle init command. Okay, so I have used this command, and there are some more documents or information you can get from here. So like Solidity contracts, scriptable deployment files, and configuration of files. So all the documentation is available on this website, so you can go to this website anytime and you can read in more details on this website. So on the next lecture we are going to write down our smart contracts in the Truffle, and we are going to test and deploy them in the upcoming lectures. So we will meet in the next lecture. Thanks for watching. Hello everyone. So in the today's lecture we are going to see how we are going to write down our smart contracts into this Visual Studio Code. Okay, so this is the structure that we have created in the last lecture. Okay, so this is the Truffle file structure that we have created in the last lecture. So it has all the folders that we have seen in the last lecture, like contracts, migration, test, and truffle.js files. Okay, so now we have to start with the contract. Okay, we already see our fixed supply token contract in the remix in the earlier lectures. Okay, so in this lecture we are going to write down our main contract, that is the exchange contract, which will contain all the functionality for the exchange. Okay, so let's get started with the writing down that smart contract. So what we need to do is that we need to go to this folder first, that is this contracts, and click on this and just create a new file here and give it a name. So if I am going to give a name like exchange.sol, so this is my exchange solidity file, and in that I need to declare my compiler version using this pragma keyword. So pragma solidity, so I am going to use 0.4.23 solidity compiler for my program. Okay, so this is an error of this Visual Studio Code, so just go to here and make this LF. Okay, that error will be gone. And after that, what I need to do is that I need to write down the smart contract. Okay, this is the actual main solidity file which will contain all the exchange functions. Okay, and for this I also need to import some another solidity files, but that we have not created here. Okay, so we will import those files after some time. I need to write down this import statement. So in the next step I will be prompted that we need to import those files. Okay, so just remove those names, maybe we'll import these things after the creation of those files. Okay, we need to create those two files, and we need to import those two files into this exchange. Okay, but we will do that latter part. Now I have to do the contract structure. Okay, so in this lecture what actually we are saying is that we are just going to write down the general structure for our smart contract. What are the functions that we are going to implement in this exchange solidity file, that just we are going to implement. Okay, we are not writing the inner code for those functions, we are just writing down the functions here, and I will tell you the structure details, and I will explain everything in this smart contract. Okay, so first of all we need to declare the contract. So just write down the contract, your exchange, and is owned. Okay, so this is the solidity file that I need to create here. So just create that file, that is own.sol, and if we want to import, just import that. Okay, okay, so this is the contract that I am going to write here. So in this first of all I need to generalize the structure for the token. Okay, okay, so just like we are going to implement the things like token structure. After that we need a structure for order book, in which we will store our buy and sell orders. Okay, and after that we need a structure for offers. Okay, so we need three structures. Okay, so I am going to use the struct keyword for this. So struct, so as we have seen earlier in the earlier lecture, what is the struct and how we use that. Okay, the struct, and I am going to make it like this as a token. This is the first structure, and after that I need another structure for my offer. So struct offer, and another struct for my order book. Okay, so this struct will contain this structure for the token, like their symbol name, what is the name for that token and other things. Okay, just like that. So all these struct token, struct offer and struct order will have the different structure in which they will contain the structure for that particular thing. Okay, so after that what we need to do is that we need to add up mappings. Okay, that will store our tokens. Okay, so for that I need to write down the mapping, and I am going to use event 8. Okay, so this is the syntax for your mapping. So token. Okay, so this mapping will be used to store the tokens, so that's why I used the mappings. Okay, and also I need to use symbol name index, sorry. Okay, that will store my symbol name indexes. Okay, if there are a number of tokens which has the different names. Okay, so that time I need to store those different symbol names into this symbol name index. That's why I need this variable. Okay, that is event variable. Okay, after that what I need is that I need to check the balances first. Okay, so for that we are going to implement two balances. First is for ether and second is for our token. Okay, and so for that also I need to use the mappings. Okay, so write down the mappings. So mappings, and for that particular address I need another mapping. Okay, that will give me whatever may be the token balances that I am converting into event finally, and this is the token balance variable for particular address. Okay, so after that I also need to check out with my Ethereum balance, and for that also I need to do the mapping, and here is a simple mapping for this. Okay, so this is the simple one because here the ether is the only symbol or the only one token or the thing that is present here. Okay, but the token will have the different symbol names. That's why I need to do this complex mapping here in this above line. Okay, so now this is the mapping for my balance ETH for address. Okay, and after that I need to check the functionality now, like deposit the ether, deposit the token management and everything. So I need to write down those code also. So first of all I will write down the code for the deposit ether. So for that I need to write down the function. So function deposit ether. Okay, and this will be a payable function. I need to mark it as a payable because whenever a caller used to call this function, they need to pay some ether to this function, and then that ether will be deposited to the exchange. Otherwise that operation will be failed. Okay, so this is the just a very simple function for deposit ether, and just like that I need the function for withdrawal also. So function withdraw ether, and I need to pass the amount here. So uint, so amount in V, okay. So as we have already know what is V and what are the units for ethers, okay. So this is the smallest unit to measure the ether, right, like your cents in dollars. After that I need to write down another function that will give me the balance. So the function name will be get ATH balance in V, and I does not need to pass anything here, so I am making it okay. But this is the get ether balance things. So this function should return the balance of that particular ether address, okay. So I need to write down the returns, okay, and it will return some event, okay. Okay, so this is the function for your ethers. After that, the same function we need to write down for our token. So just write down the same functions to deposit token, and in this I need to pass the symbol name, because there will be numerous amount of token symbols. So in which symbol we need to deposit this amount of tokens that we need to describe. So for that we need to pass this symbol name here. So that is a string, symbol name is a string. So for that I am going to pass this symbol name here, okay, and the amount, how much amount of tokens you are going to pass to this function. So amount, and just like this, okay. And the same way what we can do is that we can write down the function for withdrawal also. So withdraw token, and in this I also need to pass this symbol name. So symbol name and event amount. So which type of token we need to withdraw, and we need to pass the amount of tokens that we need to withdraw, okay, to this function. And after that we need the balance, okay. So for that, so I am going to write down the function for get balance, and in that I need to pass down symbol name just, okay. So for that particular symbol I will get the balance, okay. So this will return me the balance. So returns event, okay. I also, what I can do is that I can make these things constant, okay. We have already seen the constant thing, so I can mark this as a constant, sorry, or view. You can use whatever may be the things. So you can also use views or constant, so both are the same, okay. And if I go into here, I can use a constant also. So view and constant are the same, so whatever the thing that you want to use. You can use both the things in the same program, or you can use a view or a constant in the both the functions. So that is your choice. Okay, so now we are done with our functions for the ethers and function for the tokens. Okay, after that what we need to do is that we need to write down the functions to do the operations like add the token. Okay, so the add the token, what will that is not your deposit token. Okay, the add token will add the particular new token to your exchange. Okay, so like if you are exchange if you want to add a token named ABC into your exchange, so that time you need to first of all add that symbol name into your exchange first, and after that operation then and then you can deposit the ethers with that name. Okay, so that is a simple logic. Else if you are if you don't add that token to your exchange like ABC for example, and if you go and directly call this deposit token function, then this will give you an error because the token named ABC or the symbol name ABC token is not present in your exchange. So for, whenever you want to add some tokens or some new tokens into your system, first of all add their symbol name into your exchange first, and then call these operations on that. Okay, so for that I need to use add I need to write down the function for that also. So function add token, and in that I need to pass on my symbol name. Okay, symbol name, and I need to pass down the address of the ERC20 token address that I will get. Okay, when I deploy these things, token address, and this function only be run by the owner, no other else will able to execute this. Okay, because this is the very important function. If someone without the owner of the contract came to your this function, and if he adds some vulnerable tokens to your system, then that is your problem. So always make this function as the only owner, so only owner can be able to execute this function. Okay, so this is the add token function, and just like that I also need to check the things for that. If I need to if there is an example like I need to add some token, or I need to deposit some token to my exchange, so first of all I need to check with that token name or that token symbol is present in my exchange or not. Like if there is a two tokens present in my system like ABC and XYZ, and if I go and I say that I want to deposit TRY like token, but that token is not present in our system, so that operation gets failed. So to check that thing before that operation the user will go proceed, so we need to check that the system should have that particular name token. So for that we need to write down the function which will check the token, that is a hash token. Okay, and in that I need to pass on the symbol name. Okay, so symbol name, and this will constant or view, whatever constant, and it will returns you the boolean value here, true or false. Yes. Okay, and another the function for this I need is to get symbol index. Okay, because there may be different types of tokens, so I need to get the particular symbol index. So for that I need to write down this function also. So function get symbol index, and that is a string symbol name, and I am going to make this thing external or internal. So external and internal is like your public things. Okay, so you can make it internal, so only internal functions can call. This will returns you the uint. Okay, so uint 8 or 256, whatever may be the length of your symbol index. So according to that, put that things. Okay, there. So this is the function for this. So these are the functions that we have written down here. So we need to write down another functions also. Okay, so like order book things, sale orders and other things. Okay, so those things we will see in the next lecture. Thanks for watching this. Hello everyone. So in this lecture we are going to continue with our last lecture file, that is exchange.solidity file. Okay, so we will continue in this lecture is that we are now to implement that our buy orders, our sale orders and everything, and for that I need to write down some functions. So for that, first is our function for buy order book. So function get buy order book and pass your symbol name here, that is the string symbol name. Okay, and this will return you returns an array of uint. So whatever may be the buy orders present in your exchange, those will be written by this function, that is a get buy order book. So just complete this here. And after that, same functionality I need to write down for our sale order book. So function, or you can copy this function from here also and paste it here, and just change the name here, that is the sale order. Okay, and other things are the same. After that, what I need to do is that I need to write down the functionality for the buy tokens, okay, and for the sell tokens, in which we are going to pass the three things. The first is the which token we need to buy, that is its symbol name, okay, at what amount of price in V that we want to buy that token, and how much amount of token we need to buy. So these three things we need to pass into this buy token thing. So for that I need to write down that function also for that. So buy token, and in that I need to pass string symbol name. After that, uint your price in V and uint amount. Okay, so these three things you need to pass to this function. and the same like for your cell token. So for function cell token, here also you need to pass these three things: symbol name, event price in V, and event amount of token that we want to sell. Okay, so these are the two functions that are very important in our exchange. And if anybody wants to cancel his order, okay, limit order, so for that what we need to do is that we need to write down the function for that also. So that is a very simple function for that. So cancel order, and in that we need to pass some things here, okay, like symbol name, so string symbol name. After that boolean value for is it is a sale order or not to check, and event price in V, and offer key, that is the offer value. So I need to pass these things, and my order will be get cancelled. Okay, so these are all the functions for my exchange. Okay, so now I need to import the file. Okay, so we need another file, that is our fixed supply token. So fixed supply token that I am going to use. So just make that import here, that is fixed supply token .sol. Okay, so we will write down the code for this file in the next lecture. Okay, because there is some problem it is showing me, because all these two files are empty. So we will meet in the next lecture, and we will continue with this own.sol and our fixed supply token.sol. Okay, so thanks for watching. Hello everyone. So in the today's lecture we are going to write down the code for this own.solidity. Okay, and we are already see this fixed supply token solidity file in the remix in the earlier lecture. Okay, so that file I am going to copy and paste from my notepad. Okay, so that is the same code, but that code we require in our project. So it has all the functions. So just change to LF here. And we have already I have already explained this code to you in the remix. This is the just basic ERC20 interface, and it has all the functions. Okay, like total supply, balance of, transfer from, approve, allowance, and that we have already checked in that remix lecture. Okay, so this is the just file for this, and after that what we are going to do is that is the own solidity file that we required for this. Okay, and that code I am going to write down for that file. So for that I need to go to this own.solidity file, and I need to write down this pragma compiler first, that solidity, and give the version, that is 0.4.23 version that we are going to use in this, like this lf. Okay, in this file I am going to write down the contract for the owner address. So contract owned okay, and in this file I am going to write down the function and the one variable for the address. So address owner is the variable that we need to store the owner's address, and after that we need to write down the function, and that is owned, and in that I need to set the value of the owner with the message.senders value. Okay, and what I can do is that I can check the condition. Okay, that is my if condition here, that is if message.sender should be equal to owner okay, but we have already, what we have done is that we have passed this only owner thing here. Okay, and that is the modifier that we need to implement here. So for that I need to write down the modifier here, that is only owner and in that I am going to check this condition. Okay, so this is the syntax for the modifier. Okay, and this is the code for this owned file. I need to change the lowercase here, and so my all errors will be gone. Okay, so now we are done with our contracts, that own.solidity and fixed supply token dot solidity file. Okay, in the next lecture we are going to write down the variables and the internal structure for the token offers and order book. So we will meet in the next lecture and we are going to implement each and every function in detail. So we will meet in the next lecture. Thanks for watching. Hello everyone. So in the today's lecture we are going to implement some functions code and the struct that we have mentioned in the earlier lecture. So we need to write down some code in this lecture. Okay, so let's get started with the token first. So here we need to add the symbol name, okay, token address contract, and the mappings for our buy book and sell book. Okay, so for that you need to mention those variables. So first variable you need is the symbol name for that particular token. So symbol name. After that you need the address of the token contract on which it is deployed. Okay, after that we need the mappings of the order book for our buy book and sell book. So that will contain our current price, lowest price, and the amount of buy prices. Okay, so for that we need to declare those variables also. So first of all I need to declare the mappings for that. So mapping event, and that is order book, that is for buy book, and here I need to describe the current price, that is a current buy price. After that, the lowest buy price for this buy book mapping, and the amount of buy prices. Buy prices. Okay, so this is the mapping for the buy book. So the same you can do is for the sell book. So for that you need to write down the same code. That is order book, sale book, and in that also you need this same 3 variables. So first is your current sale price, just change this to your sale price, just change those variables here. Okay, so now we have done with our struct token. So this token structure will contain this type of format inside it. Okay, after that we need to go for the order book first. Okay, so for that the order book will contain your highest and lowest prices. So for that you need to mention the variable to hold the values, that is event higher price, event lower price, okay. And in the order book I also need to check out with my offers. So for that I need to do the mapping here. So mapping event with the offers, sorry, offer, and in this and I need to mention the offers length and offers key. So offers key and offers length. Okay, so if for example there are 4 offers in your in your order book, okay, so that time the offers length will be 4, and if there is no any so all those order are present in order book and there is no sell order that time, okay, so your offers key will be the 0. Okay, so now we have done with our offers book also. And another thing that we need to declare the offer amount. So for that I need a variable, so this is the variable for that, and the address of the person who offering the offer. Okay, so this is the struct token offer struct and your order book struct. Okay, now what we have to do is that we need to go to our get symbol index. Okay, and in this we need to check that we need to check our symbol name index here. Okay, and for that we need to check the comparison also. So for that I need to use for loop here, get to 56 or 8, whatever maybe you want. Initialize with value 1, that is your I is less than and equal to your symbol index name. Okay, I plus plus. So okay, so here you are passing, sorry, so here you are passing the symbol name here to this method. Okay, and here you are iterating through your symbol name index. Let me check with my variable, that is symbol name index here. So this index will contain all the your indexes for your different types of tokens. Okay, so I need to go through all the symbol name index here. Okay, and I will iterate through this, and then I will check that my token symbol that I am getting from the user and my symbol name should match. Okay, so for that I need to write down the string equal function. Okay, that you will find on the internet also. So that is a string equal function for solidity. So that is a ready-made function that you can use. Okay, I'm going to write down that. Okay, so in solidity actually the strings are of the type UTF-8. okay, so whenever you save those strings in a memory, so those strings will be saved as a byte. So remember these things. So I need to cast their things. So this is the ready-made function. Just I am writing down the code. You will find this on the internet also. So I am here checking the length of the two strings. So if those are not equal, then I will return a false. So return your false. Okay, and also I need to iterate through my length. So for that I am going to use for loop here. So I is equal to 0 is then length of a dot length and I plus plus. Okay, and if E of I is not equal to B of I, return false here also. Okay, and if it is equal, then return true. Okay, so this is the string equal code. I need to write down this string equal function. Okay, and in that I need to pass my token symbol, symbol name index with the tokens I. Okay, that is a symbol name, and the symbol name I am passing through this function directly. So this is this symbol name, and I will return its index. So return I here, and if it fails, then return 0. Okay, so this is the get symbol index. Now there is another function that will check that our exchange does have that symbol name for that particular token or not, means that token is present or not. So for that we have already declared this function, and in this I need to check, that is the symbol name that I am passing here, and I will get the index of that particular symbol name, and if I am get the value of 0, then that means that token is not present in our exchange. Okay, and if I am getting some another value other than 0, then our token exchange has some token with that symbol name is present. Okay, so just for that, make some human variable, and in that pass this method here. So get symbol index. Okay, and in that pass here symbol name, and just like I said, if you get 0, means that your index value becomes 0, or you will get 0, you will return false. Okay, or else you will return true. Okay, so now we have already now also we have written this thing. Okay, now there are also other functions there, but after this we need to write down this add token to the exchange, and this can be add or invoked by only the owner. Okay, so for that, first of all I need to check using require that my token has this has token method. Okay, and I need to pass the symbol name for which I am adding the token. Okay, if that token is already present with that symbol name, okay, then this will revert the operation, it will not go further. Okay, but if there is a no token present with that symbol name, then we need to add that token. Okay, so for that, first of all, we need to increase our symbol name index. Okay, because we are adding another token here, so just increase this symbol name index first, then store your new symbol name into token symbol name index. So tokens, because you are passing the two variables here, the symbol name and ERC20 token address. So tokens and your symbol name index. Okay, and in which you need to store this symbol name, and in another line you need to store the ERC20 token address. So the line will be the same, the tokens symbol name address, in that is a token contract, and in this ERC20 token address. Okay, so whenever you invoke this function, this will first check that if that token is always present or not. Okay, if that is present with that symbol name, it just revert the function. Else what else it will do, it will increase your symbol index, okay, by 1, and after that we will store that symbol name and ERC20 token address to our contract. Okay, so now we have done with our token code things like add token, hash token, and get symbol index. In the next lecture we are going to see more functions. So thanks for watching this. Hello everyone. So in this lecture we are going to write down more functions code. Okay, so let's get started with the deposit ether. Okay, so for that, this is the very simple code for this. Okay, here we need to deposit ether into our exchange, and for that what we need to do is that we just need to pass the amount of ether value to this balance ETH address. Okay, for that particular sender. Okay, so for that I need to do this. For that particular sender, I need to just need to add the message.value that message.sender has passed. Okay, so this is the just one line code here to deposit the ether. Okay, and if you need to check the overflow thing, that time you need to require the function for this. Okay, so require, okay, if that condition goes fail, then it will just revert it. So here I am going to check that my balance that the message sender it's sending plus its value. That is greater than or equal to the message sender dot value. So I am just checking here with my things overflow. Okay, now I need to write down the code for the withdraw function, withdraw ether, sorry. So for that, this is also very simple. I need to pass the amount in V that I need to withdraw from this exchange. Okay, so I just need to minus the balance for that particular message sender with that particular amount that he wants to withdraw. So it is just like the same. function or line of code like deposit ether. Okay, and I will just transfer that amount to that sender. So message sender, I will call the transfer here. So this is the ERC transfer function, ERC20 transfer function, and amount in V I will pass here. Okay, and if I have also to check the overflow, then I can check those things also. So it will be the same here, like this line. I just need to change here, that is minus amount in V should be less than and equal to balance ETH address for that particular sender. Okay, and to get ETH balance in V, I just need to return the balance for that particular message sender's address. So I just need to return the balance ETH address, okay, for this address here with the message sender input. Okay, so this will return me the ether balance in V. Okay, so this is the functionality for ether, like depositing, withdrawal, and to get balance. Okay, so if we go to our deposit token thing also, you will find the same code here also. Okay, so for this also I just need to insert the symbol name here. So for that it will be the same thing, just I need to add this code here. Okay, so first of all I need to get the tokens instance, okay, from the tokens contract with the help of ERC20 interface. So for that I need to write down the ERC20 interface. Okay, and in that I need to pass that symbol name index, and I need to get the token contract. And I will save this into a variable. Interface, that is token, and in this I just need the token balance for address. Okay, so just like this, deposited ether, the balance ether ETH address. So now I need a token balance for address. So token balance for address. Okay, I need to store the deposited amount that I am passing here for that particular message sender. So message sender with that symbol index. Okay, so with that symbol name index I need to plus that amount. Okay, so this is the same code for the your deposit token also. And if you need to check the overflow, you can use the same logic here. Just you need to copy and paste here and just change the things like ETH token balances for addresses and this. Okay, other logic will be the same, and just here I am not sending the value in ethers, so I am just adding the tokens. So I need to pass on the amount here. Okay, and this is it. This is the function for our deposit token. And same logic we can use for our withdraw token function. So for that also I just need to copy this line these two lines from here. I just need to paste it here. Okay, and just I need to minus this amount here, and the same line will be here also. To check the overflow, just make this minus and make this less than. So this is the withdraw token function. Okay, another thing that I just missed out here is that we actually need to get the symbol name index first to deposit the token or to withdraw the things. So for that I need to get this symbol name index value from get symbol method, get symbol method that we have already written here. And I need to pass the symbol name. Or you can use or throw here. If it don't finds, it will throw an error. So just copy this line from here and paste it here. Now I need to write down the code for this get balance. It will be very same like your ETH balance. Okay, so for that I need to first get the index, symbol name index from this method, and after that I just need to return token balance for address. Okay, that is message dot sender, and your symbol name index. So this is it. So now we have we have done in this lecture is that we have written the code for deposit token, ether, withdraw ether, and getting their balances for the token and ether each. Okay, so in the next lecture we are going to write down more functionality for this get buy order and sell order things. Okay, so we will meet in the next lecture. Hello everyone. So in the last lecture we have seen the deposit and withdrawal function for ether and token. Okay, so in that functions we have written down this get symbol index or throw method, but we have not implemented that function in our solidity file. So now let me implement this thing here. Okay, so that will work. So write down a function for that. So that function is for just returning the index for that particular symbol. So write down the function get symbol. Let me copy this. So get symbol and pass the string, that is your symbol name, and returns, and it will returns you the index. Okay, and for that I need to copy this line again. Okay, and I just need to paste it here and do the changes, necessary changes for this. So this is the same function, just change your variable to index and just call the get in symbol index method that is present here and pass the symbol name. Okay, and this function should return you the index for that particular symbol name. Okay, so this is the function for this. Okay, after that what we need is actually after that we need to write down the functions for our buy token and sell token. Okay, so first of all we will start with our buy token, and in this buy token, as you see, we are passing these three parameters here: the symbol name, price in V, and the amount. Okay, so first of all we need to copy and paste that line to get the index of that particular symbol. Okay, for which we are requesting the buy token function. Okay, and after that we need to define two variables. Okay, that is the total amount of ethers necessary and the available ethers, right? So for that you can use the total amount of ether necessary as equal to 0, and the same is for this. That is available, just change here and initialize with the 0 value. Okay, and if we have it, we need to calculate the amount of ethers here. Okay, so if there are enough ether, then we can buy that. Okay, so the total amount of ether necessary for buying the token we can calculate using multiplication of amount, okay, with the price in V. So we will get the ether value, the exact ether value. Okay, and I need to store this into this total variable. So just let me do that. Okay, so here I will get the necessary ether necessary to purchase or buy the tokens. Okay, after that what I have to do is that first of all I need to deduct the amount of ether from my balance, okay, to buy the tokens, and for that I need to call this balance. So let me copy that because of the syntax error may I get. Okay, so it is for address. I need to pass the message dot sender. Okay, and in this I am going to minus my total amount necessary, so this variable here. So here I am deducting the amount of ether from my balance first. So whoever want to buy this token, his balance should be minused or get deducted first. Okay, and then he will be able to buy the tokens. After that I need to check that if there is a already seller present, okay, and if my condition for asking price or say buying price is okay, then I will execute the market order directly, or if there is a no seller, okay, then I need to limit the order, okay, right, because of there is only buyer present, so I need to take his order and need to put into the order book. Okay, so for that what I need to do is that I need to write down the if condition, okay, and I need to check that if there is any sell prices or not, means there is any seller or not, so that I can check with this code. So that tokens, and in that token name index, and that is the amount sell prices, that is equal to 0, and or okay, if there is a no seller present, that time I will convert this order and save this order to my limit order. Or there is another condition, okay, if the current price, okay, is higher than my price in a V, that is my asking price, and then also I am going to save that as a limit order. So again the same thing, I just need to copy from here, I will paste it here, and my current sale price, if it is greater than my asking, so it will add to my buying offer. Okay, so I need to add this. Okay, so add buy offer, and in that just pass your token name index, price in a V, and amount in message dot sender value. Okay, so this is the function. This is a very big code that I am going to write down the function for this. Okay, after this I just written down this line, and I will write down its code after the creation of this limit order. So if there is a no one, I need to create my limit order, limit by order. So limit order created here, so I need to pass the things here. So first is my token name index, Okay, after that the message sender value, so message sender, then amount, then price in a V, and then token in this buy book. Okay, and that is a buy book, and in that price in a V, that I need to offers length. Okay, so I will create a buy order, limit order for the buy order. Okay, so after this I need to write down the add buy offer function. Okay, which will have all the related logic to place the buy order offers according to that. Okay, so and I need to just, if I need to write down the else method here, so else and just revert it. Okay, so revert. Okay, so if the limit or if there is a seller present for that particular buying order, okay, and that order will be directly executed in this else. Okay, so that order will be executed like market order. So this is our buy token function. So I need to write down then the add buy offer. So that code is very big, I need to copy and paste that code here, and then I will explain it to you. I need to pause it here. Okay, welcome back. So now I have pasted the add buy offer code here. Okay, this is a very large code and complex code. Okay, so here what I have done is that I have actually in the first line I actually increases the pipe size of the offers length. Okay, so whenever the new add buy offer comes in, okay, that will be added to our pipe. Okay, so it does not need to initialize because when we do mappings, okay, that is already initialized with the default value 0. Okay, so if there is a first order comes, okay, then the length of an array offers length will be 0. Okay, and when there is a second order come, then that size of that will be of 1. Okay, so actually this is a very complex code, okay, in which I am I need to show you the simple way what I am doing here. Okay, so this is the case here. Okay, suppose there are 3 buy orders come. Okay, so in the first thing, if the first order comes, okay, and the price is 540 for the volume of 254 tokens. Okay, so at the add buy offer we actually do the linked list of all those prices, okay, with that tokens, and each buy offer has this states like next value, okay, and the last value and the number of volume of tokens. Okay, so these 3 things are binded to this particular buy offer. Okay, so if there is a first order, so that time what is happened here is that its next value will be saved as a its next value will be stored as a 540 in the first place, okay, not a 555. Okay, and its last will be 0 because it's the first one and the volume is 254 tokens. Okay, and when there is another order comes, okay, so that time the values of the last one will be updated like this one, so its next value will be updated to 555. Okay, and its value will be updated like this. Okay, and if there is another one at the upper side here, okay. So those prices will be updated like this, okay. And if there is an order comes like this, okay, price is 570, okay. So that time what happened is that, so that time I just need to copy this, let me explain this to you, okay. So that time the next price will be 590, okay, but its last value will be of 555, okay, and whatever may be the volume, like it's 50 volume, okay. So if that order comes, okay, that will be adjusted in a linked list in between that, okay, and those linked list will be arranged with the price things, because it needs to be executed according to the seller's orders, right. As a seller comes, automatically according to that, those buy orders, okay, will be executed in this, okay. So this is the logic here, okay, and I have explained here. So this is the logic. So like just like here, okay, here I am setting the lower and higher prices in this, okay. So the current prices I am setting here, okay, with this code, and here the lower prices I am setting like this, and I am checking the condition to insert those things like this, okay. If there is a current price will be 0, like this is the first one, okay, there is no buy order yet, like, then we will insert this at the first place like this, okay. This is the first order, okay, else or the lowest one, okay, and just like that, if else I am doing, and just like I showed you, if someone comes in the middle of that range, that will be adjusted with this code, okay. So this is very self-explanatory code that you can go and check out, okay. So this is it for this lecture. In the next lecture we will continue with other functions. Thanks for watching. Hello everyone. So in the today's lecture, what we are going to do is that we are going to write down some test cases for our smart contracts for this gradient token, and for that we need to create the test file in the test folder, okay. The Truffle has a very good testing framework inbuilt, because it uses Mocha and Chai for their test scripts, right, okay. So all the files that we are going to use in this test folder, those are all JavaScript files or JS files. So to write down the test scripts, we need to create a file in this test folder. So give it a name, gradient token test.js, and this file we will run, and we will write down the code in that, okay. Truffle, and what is the structure that the Mocha or this Truffle actually supports, okay. So for that I need to first explain you some of the functions that we are going to write down in our project for the testing things, right. So first thing is that what are the functions that are supported by this Truffle testing framework, right. So let me write down the functions and their purpose here, okay. So we are going to use IT, that is it, and its purpose is to run a test and make an assertions, okay. After that we are going to use describe, which groups its statements. So whenever you have many if statements in your test cases. Okay, that time you can use, and you have to use this describe function. So it groups together all the it function. And third one is a before each. Okay, so it executes some of the general setup code. So execute some general needed or setup code, you can say. Okay, so these are the functions that we are going to use in this truffle testing framework. Okay, so it is used to run a test. So whenever you have to check some contract function, that time you have to use this it function and write down the testing code in that it function, and then it sorry, I think here is the ms dog, and after that it make an assertions on that. So we need to describe this it function in the test. After that, if there are too many it functions in your test, that time you have to use this describe function. So it just groups together all the it functions, and before each function is used when you have some code that need to be initialized or need to be set up before each test. That time you can use this before each function. Okay, so now I am going to show you some just basic example that how we are going to write down a test. Okay, that is not a real test. This is just an example that I am going to show you. So you will get an idea how we are going to write down the real test for this smart contract. So let me enter here. So here now I am going to write down a example class. Okay, so if I mentioned a class, okay, class like a car, and in that I want to test a park function, okay, which returns me stopped, and another there is a drive function that I also wanted to test, and it returns me vroom. Okay, so now I wanted to this is my class and these are my functions, and I wanted to test these functions whether or not they are returning the same result that I wanted or that I mentioned here, or they are making some another result. Okay, so what in the testing, what we actually check is that the result that we wanted or that we have mentioned and the result which is generated by the code is the same or not. So that is the assertions that we need to make in the test, right? So this is just a class. Now I have to write down test cases for this. Okay, so for that I am going to use this describe function. So describe and in describe function I have to mention two parameters. Okay, first is the comment that will describe you okay which thing is executed, and so it will just for the reporting part. Okay, so whatever you may want to add up here, you can add up. Okay, so for example I can add up like a car or car test, something like that. Okay, so if I put this like a car test, then I can say here like that. Okay, and after that I need to give the second parameter, and that is the arrow parameter that I am going to give here. Okay, so that is the syntax for this is like this. Okay, and after that I need to mention the test code in this. Okay, so as we have mentioned earlier that we always mention the testing code in it function. So I need to write down it function here. So it, and it also takes a two parameter. Okay, first is the comment parameter. You can put anything here. Okay, so I say like car park, or can I park. Okay, and after that also I need to put the arrow parameter here. Okay, and in that I need to mention the code. Okay, so for that I can assert here. Okay, so assert equal car.park, and I am checking with this value, that is stopped. Okay, so what is I am checking here is that I am checking that whether the code generated thing or the result is the same that I wanted in this lecture, or I wanted in this assert is the same or not, right? So if I run this code in a Mocha or in this Truffle, okay, but we are not running this code right now. Okay, this is just an example. So I think if I run this code in Mocha or in Truffle, so it will give me or it should return me this top stage, right? And if it is it gives me some other results, okay, in this parameter, and this thing is different, okay, then that test you can say it is a fail one. Okay, so it fails because the code generated thing or the result is different than what you are expected here, right? So also before this I need to call this class, because class is outside of this describe and it function. So I need to make a variable for this, that the initialization of the class, right? So new car. Okay, so this is just an example. It is giving me an error, something like that, but I am just showing you how we actually write the code for the tests, right? So it is not a real code. Okay, after that I also can write down the code for the same, that is for the room function. So I am just going to copy this and paste it here. Okay, and I'm checking that room. Okay, and okay, so this is the way by which, okay, let me change this also. I need to change this drive. So okay, so in this thing we always assert that whatever may be the result should be equal or not, and upon that our test is either pass or fails, right? So we have seen these two things in this in this file. Now I am going to show this before each function. Okay, so when to use this before each function. So whenever you have a code that need to be initialized, or that you need to run before each statement, okay, that you can put in that before each statement. Okay, so for that you can write the code like this. Okay, so before each I am passing this arrow parameter here, and in that I can say something like that, log dot e or something like that, and logs. Okay, so how actually this before each function runs, right? So whenever you run this file in the truffle, okay, so whenever you run the test one by one, so before each test, okay, this file or this log will be run before each test. Okay, like that, this will run, okay, first, after that this will run, and again this will run, and after that this will run. So this is the flow of this before each statement. Okay, so in our example, here you can see that we need always this initialization of the car, so that we can use here. Okay, so we can remove this and put this here, and we can remove this and put it here. So whenever you run this test, so what this before each do is that it always initialize this car class before each test case or each statement, you can say. Okay, so another thing that you have to think is that if you are going to run this code in a truffle, it will give an error of this car variable here. Okay, because it is not defined in this function or in this describe, so it is not accessible by this car variable. Okay, because it is outside of the scope, right? So for that, what we can use, that we can remove this constant. Okay, this is the constant. So when we use a constant variable, so whenever there is a no value change for a particular variable, that time we can use a constant. Okay, but if the value of the car it change for each iterations, okay, so that time you have to use let keyword. So you can use let car keyword. So here each time the value of the car changes, and you can use that value by using this let variable car. Okay, so this is how actually we write down these functions here. Okay, so sorry, here is the problem. Okay, so this is how we actually write down the test and things for this. Okay, so by this way we are going to test the code or the smart contracts using the test cases that we are going to write down in the next lecture. I should have to mention here that in the test cases we also going to see this functionality called async and await. Okay, so it syncs the things. Okay, its name is async. Okay, but it syncs the proper things, it syncs the proper code for your test cases, and wait for the particular things to be happened, and after that it will run the next code. So this is also the things that we are going to see in our next lecture. So in the next lecture we are going to write down the real test cases for this gradient token. Okay, so we will meet in the next lecture. Thanks for watching. Hello everyone. So in the today's lecture we are going to write down some test cases for our smart contract. So for this tutorial I am going to write down just for one test case for my fixed supply token. Okay, for that I need to create a file in my test folder, and I am going to give the name, that is fixed supply token.js. Okay, in this file I am going to write down the test cases for this. So first of all, start with the variable and supply your fixed supply token dot solidity file. So write down artifacts, and it, so this line actually will be required actually, which tell us this file that this is the main contract, that is the fixed supply token dot sol. After that, I need to check that first account should own all the tokens, and for that I need to write down the contract. So just call the contract and pass the name in a string, that my token, and your function account, and pass your accounts here, and in that write down its statement, and in that pass your string, whatever string you want to pass. That is the first account should own all the tokens. That is what I am checking in this first it statement, and after that I need to write down the function for it, and in that function I need two variables. That is the first is the total supply function, variable, and second variable I will use for my token instance after the deployment to call my contracts. So just write down the second variable here. Okay, after that I need to check whether my fixed supply token is deployed or not. For that I am going to write down this code. So fixed supply token deployed, and after that if it is deployed, then call the instance, so function instance. Okay, and after getting this instance, save that or assign that instance to my token instance. So my token instance is equal to instance. After that just call the total supply. Okay, so my token instance dot total supply dot call. Okay, and return this, and return this also. Okay, after that, okay, return this. After that, if this function gets successful, then I need to write down the then function, and in that I will pass the total supply, and I will set that total supply to my underscore total supply function variable. So total supply variable is equal to total supply, and I will call the balance for the first account using my token instance. So my token instance dot balance of the account 1, that is account 0 from position 0. So for the first account, so I will get the balance of the first account here and return this value here. After that, just again call then function and get the balance account for that owner. Okay, and in this I need to assert, okay, to check the system generated output and what I am expecting. Okay, so just assert equal, and in that balance account owner dot convert it to number, and check with the total supply that we got. So we will assert these two values, means compare these two values, and if this becomes successful, okay, I will show this that total amount of tokens is owned by owner. So this message will be displayed in the console. Okay, after that we will return this fixed supply token here, and after that I need to test another it statement, that the second account should not own any tokens, right? This is another test condition that I should check. Okay, for that I need to write down the same functionality here. So you can also copy and paste, but I am writing down this. So the second account should not own any tokens, and write down the function. Okay, and after that just write down a variable here to save your tokens instance, and after that just check whether your fixed supply token is deployed or not. Then if it is deployed, then call the get the instance and save that instance to that variable, assign that instance to that variable. So my token instance is equal to instance, and just check the balance of account 1 using my token instance dot balance of account 1. In the earlier case we checked for 0, now we are checking the account 1, that is the second account. Okay, and return this, and after that just call the then function. If this becomes successful, okay, if we get the results, then just assert equal balance of account owner okay, and check with the value 0, because in this we are going to check and comparing the value with 0, because the account owner balance account owner should be 0, and if it is not, then I will display this message, that is total amount of tokens is owned by some other addresses. Okay, so this is another it function, and return this thing. Okay, after that I am going to write down another test that in that I am going to check that whether should my token sent correctly or not. Okay, for that I am going to write down another it function. So it, in that I am going to write down my string that it should send token correctly, and write down your function. And here I need some variables, like a variable token to store the tokens instance, and I need to get the initial balances of first and second account. For that I need some variables. For that I am going to write down variable account 1, and I will save assign account address 0, that is first account. Copy, paste it here, make it 1, and change it here 2. So I will now have 2 accounts addresses. After that another variables I needed, like account 1 starting balances or starting balance, and after that the same I can copy and paste. Okay, that is for 2. Okay, and the same I can copy and paste, just change here, that is ending balance for account 1 and the ending balance for account 2. Okay, then I will pass the amount of token that I need to send correctly. So amount variable amount is equal to 10. So I wanted to test that whether my tokens 10 tokens are sending correctly or not. Okay, after that I will deploy my fixed supply token. I will check that using fixed supply token dot deployed, and I will call then instance, and as I get the instance I will assign this instance to my token variable. So token is equal to instance. Okay, and after that I will call the balance of function, okay, using token balance. Okay, token balance of, and call the account one. Okay, the same you can copy and paste here, or we will write down the then function and then we will copy and paste. Okay, so the function, and we need to check the balance, so just write down this. I'm not going to copy and paste because it's a change. So account one starting balance, so I'm assigning the balance that I'm getting, converting it to number, and I will call the balance of account 2. Okay, after that I'm going to pass this to, I need to check the transfer function using then. Okay, so here I will go and pass the balance here, and here I will call the account 2 starting balance. I copy and paste it here. Okay, and just change this to 2. Okay, after that I need to call this transfer function using token instance. So token dot transfer, and I am passing that amount 10 token to account 2. So account 2 comma amount variable, and I need to pass where it is, I need to pass, so from account 1. Okay, so this is a transfer function. After that again then function you can call, and in that check the balance of account 1 using balance of function. So write down token balance of dot call account 1. Okay, and return this. After that I need to again call this account then function, and need to check the balance for account 1 ending balance. Okay, in that I need to check account 1 ending balance. So account 1 ending balance is equal to balance dot to number, and again I will call token dot balance of account 2. Balance of, call the account 2. Okay, after that I need to check the ending balance for account 2. So then return balance of account 2 ending, write down your variable, that is account 2 ending balance is equal to balance dot to number. Okay, and just I need to assert these values, that is assert dot equal, that is account 1's ending balance, account 1 starting balance minus amount. Okay, and I will display that amount wasn't correctly taken from the sender. So write down this, can click from sender. Okay, and in the second line I will again assert equal for account ending balances. So account 2 ending balance and comma account 2 starting balance plus amount, okay, and I will display to user that amount wasn't correctly sent to the receiver. Okay, so this is the code for this, and just return this thing here. I just forgotten. Okay, and return this also. Okay, so this is the test cases for my fixed supply token. Okay, now I need to compile these things and need to test this whether it is correctly test or not. So I need to check it. So now I will run this test in the terminal. So open the terminal here. Okay, just compile the code first. So using truffle compile command. So truffle compile, press enter, and our contracts will be get compiled first. Okay, now it is compiling. After that, what I need to do is that I need to migrate this on my Ganache. That is a private network. So just migrate this, means deploy using truffle migrate. Okay, here you see my exchange is actually deployed. Now just run the truffle test command, and it will pass the values and test. Press enter. Okay, so here you can see that my all the three test cases that I have mentioned in this file actually get passed. Okay, so this is how you can write the test. So this is just for this is just an example that that I am here I am showing that how to write the test cases. Okay, so if you wish, you can write down more test cases for this exchange, like for deposit and withdrawals, okay, and trading. So that is the homework you can do also. Okay, but for the test cases, this is it. So we will meet in the next lecture. Thanks for watching. Hello everyone. So in the today's lecture, we are going to see how we are going to write down the code for the front end. Okay, so in this tutorial we are going to write down the code in the vanilla JavaScript using basic HTML and CSS. Okay, so on the screen you will find some file structure here. Okay, and in this file structure you will find some new files that I have created now. Okay, so in that, if you go, you will find this package.json. Okay, open this file, and in this file I actually put some dependencies that will be required for our project. Okay, so these are all the dependencies that will require for our project to run successfully on a browser. So these are the things. Okay, so we will get back. So these are actually the files. Okay, file that will contain all the dependencies. Okay, so you will find bootstrap dependency, jQuery dependency, webpack dependency, in everything. Okay, and now what I have to do is that I need to go to the terminal and need to install these dependencies. So for that I need to write down this command, that is npm install. Okay, so what this command will do is that it will download all those dependencies that were declared in package.json, and it will download those node modules into our project. So here you will find that our node modules folder is created here automatically after this command. Okay, so wait for some time to finish this installation. It will take some little amount of time. Okay, so I think it will take some time, so we will get back after the completion of this. Okay, now my npm modules are installed successfully. Here you can see. Okay, so after that what I have to do is that I have created these files, that webpack.config.js. okay, so this is the main entry point file for our project. So in this file you will find or the configuration you will find on the website. So let me show you the website, so you can go and you can find the things on this website. So this is the webpack.js org website, on which you will find all the documentation and the tutorials. Okay, but this is a very vast topic that we are not covering in this tutorial, but for your knowledge you can go to this website and learn about these things. Okay, so all these things are downloaded from this, and here we have pasted that code. Okay, so just I have to mention my entry point. Okay, that is my app.js, the first thing, and after that you will find my index pages, that is my HTML pages that I have need to declare here. Okay, so this is the ready-made file, just you need to change some little things and you can start with the webpack. Okay, after that I have also created the webpack.bootstrap config file. Okay, so this is also ready-made file that you can download from their bootstrap webpack bootstrap repository. Okay, so the website is this. Okay, so getbootstrap.com. here you can find on this website that configuration. Okay, and just paste that code into your editor. So this is also ready-made file. Okay, after that what I have done is that I created the app folder here, and in that folder I have created JavaScript folder, and in that we have created app.js file, and there is a style sheet folder also. In that app.css, all the CSS that we required for this project are created here. Okay, and I have already done the HTML and CSS coding in these pages. Okay, so this is also vast code, so I have already copy and pasted into my project. Okay, so let me show you how actually this will look like when we run this project after the code in app.js. So just install your terminal and run this command. Okay, so first of all we need to compile this code. So just compile this code using truffle compile first of all. In this also you need to run your Ganache also, so please run your Ganache here. So I have already run my Ganache here. Okay, and then run your command, that is truffle migrate. So it will deploy that code onto your Ganache, and just then, and here you will find that your contract has been created. Okay, and after that you need to run your npm run dev command to run this in your browser. So this will run your webpack browser. Okay, and you can copy and paste it in your browser here, the path. Okay, so this is the actual design of our exchange. So this is the exchange page. After that there is a token trading page, and after that there is a token management page here. Okay, and in the right hand side you will find the address, exchange, and other things. Okay, and for that I need to install the MetaMask. Okay, that I have already installed here. Okay, what you can do is that you can go to the Google Chrome Web Store and just find the MetaMask there and install that Chrome extension in your for your browser, and then start your ganache and just click on that MetaMask. Okay, and click on these networks, and here you need to click on this localhost 8545 thing, and it will connect to the ganache, and all the accounts that is web3 accounts will be imported here, and after that you can use those things. Okay, so this is it. So this is all the things that we have done. Okay, so in the next lecture we need to write down the code for our app.js and we need to import some files there. So we will meet in the next lecture. Thanks for watching. Hello everyone. So in the today's lecture we are going to write down the code in our app.js file, that is the JavaScript folder. Okay, here. So first of all we need to import some jQuery and Bootstrap loader files. So for that just write down the import jQuery. Okay, and import your Bootstrap loader. Okay, and after that I need to import the CSS pages. Okay, so for that import this style sheet and app.css from style sheet folder. Okay, after that I need to import the libraries that we need. Okay, that is web3 library for our web3 injecting. So just import those files like this. So this is the syntax for this. And we also need to import our truffle contract. Okay, so these are two libraries that we need. After that I also need to import our contracts. Okay, that is my exchange contract and fixed supply token contract. Okay, so just import the artifacts, make the variable that is exchange artifacts, and give the path here. So exchange.json, and import your another file, that is token artifacts, means your fixed supply token file. Okay, so after that I need to make the abstraction of that. For that I need to define two variables, that is a variable exchange contract, and I will save the contract address of artifacts into this. So contract, so this is just an abstraction, so I can use this exchange contract and token contract variables. Okay, after that what I need to do is that I need to add the listener here. Okay, so that is my add event listener for window. So it will check if my web3 has been injected by the browser or not. So just add this code here, that is window.add event listener here, load. After that write down the function, and just I mentioned that we need to check that our web3 is injected from the browser or not. For that I need to check the condition, that is if type of a web3 is not defined or undefined, okay, then just set the current provider to the window.web3. okay, and this is the code, that is new web3, and just set your current provider here. Or else you will set your local HTTP provider. Okay, that is your local host in HTTP provider. Providers.http provider, and just pass on your local HTTP code from Ganesh, that is in this line, and just save this file. And after that, what we need to do is that we need to write down the window app function here. Okay, and that will the entry point for our project, where I will set my initial account there. So for that I need to add, that is window app. Okay, so in that I am going to write down some code here. So that is the start function I need to write down. Okay, and in this I need to set a variable, that is variable self, that is equal to this. And first of all I need to set my web3 provider here for my both the contracts. So my abstract variables are exchange contract, and I will set the provider here, that is my web3 current provider. Okay, for exchange contract, and another is for my token contract. Okay, and after that what I need to check is that I should get the first account. Okay, so the first account initial balance to be displayed. For that I need to write down some code, that is web3.eth dot get accounts, and in that I need to pass the function err and accs. Okay, and in that I am going to check that if error is not equal to null, if okay, then I will show there was error in fetching your accounts. And if you get an error, the alert will be shown to the user. So I am taking care of that alert here. Accounts, and just return the value here. And after that I am going to write down another if condition, that is the account length, that acc.length is equal to 0. Okay, so and I will alert the user that we don't get any account. Okay, make sure your Ethereum client is configured correctly. Okay, so after that I need to save those accounts into some variables. So for that I need to define two variables. So I will define two variables here. First is our variable accounts, and second is a variable account only. Okay, so I now I need to save the account to these accounts. So my ACCS, and I will set my first account and store this into this account. So that will store my first account into this variable. Okay, so this is the window app function and event listener that we have written down the code for this here. Okay, so okay, and last thing is that I need to start this app window. So for that I need to write down app.start. Okay, so now we have written and completed all our two functions here. So in the next lecture we will define more functions into this app.js. Thanks for watching. Hello friends, so in this lecture we are going to continue with our app.js file. So now we have to set the status for our inner HTML file. So for that I need to write down a function that is a set status. Okay, so just click here and write down the set status function, and in that pass the message. Okay, open your curly braces, and here you need to define one variable for this, that is a variable status, and to which I am going to pass document.get element by id, and I will pass the status. So this is a predefined function you can use in this, and after that just set your message to your inner HTML page. That is a message. Okay, after that what I need to do is that I need to print in very important information on the screen, like the address of the token, address, active account, and everything. Okay, so those things I need to print out. Okay, so for that I need to write down another function here, that is a print important information. So write down that, so print important information. And here I need to check with my variable exchange contract that my exchange is deployed or not, and then I will get an instance. So just write down the code, that is exchange contract dot deployed dot then, and then function instance. Okay, after that I need to create a element that is for div. So I need to write down a variable that is var div address, and I will pass document dot create element div, and after that I will append that child with document create text node, and I will show the message to the user on a screen, that is the address exchange address, and I will put the instance dot address. So whatever may be the address I am getting, that I will show to the user on a screen using this line. Okay, after that I will set attribute for this div address. Okay, that is class and alert info. Okay, and after that I need to use document, and I need to get element by ID, and I will pass the string here, that is important information, and I will append my div address here, so that information will be displayed on my screen. Okay, so you just need to copy this exchange contract and just deploy the same for your token contract. So code will be the same. So on your screen you will see the address of the exchange and the address token, or address of the token. So just change these things here, that is address token. Okay, so that's it. And after that what I need to do is that I need to get accounts, okay, from web3. So I will use web3.eth.get accounts, and in that write down the function error and your accounts, pass your accounts, and in that I need my first account balance. So write down the code, that is web3.eth.get balance, and pass on your first account here, that is accounts ACCS at position 0. Okay, and just give the comma and function err1 and balance. Okay, so here I need to show another information. For that I need to create another variable, that is again the div address we can use here, and we can get the create element from document. So document.create element div, and create another variable, just div variable. Okay, it will be the same, that is create element div, and here I will show the active account. Okay, so here just div dot append child, and write down the document dot create text node, and just create active account and pass your account 0. So it will show you active account address. Okay, after that just create another variable and pass the same create element div here. And again append the child, that is for this second variable, that is div2. So, and in that create the text node and show the balance of ether, that is balance in ether. Okay, and just need to pass web3 dot from v and show the balance in v. Okay, and after that just append these all the divs that we have created, that is div and div2 with our main div address. So just div address append child div, Okay, and just set attribute that is a class alert info. And what you can do is that you can also copy this line from here and you can paste that, because those are the same lines. Okay, so this is it with the print information function and get accounts. Okay, so we'll meet in the next lecture and we will write down some more code in this app.js for our front end. So thanks for watching. Hello everyone, so we will continue with our app.js exchange file. So in this you will see that I have already copy and pasted some code here. Okay, so this is the init exchange code, and in that I call some functions like print important information. Okay, and I already imported another, that is refresh balance exchange and watch exchange events. Okay, so these are just to show our information on the screen. So this is the code for this. Okay, you will get this code in the project repository of ours. Okay, but this is just a generic code, but we are interested in our deposit ether and other code. For that I need to write down the function. So just write down the deposit ether function, and in that get the element by ID. So for that I need to declare a variable for that is amount ether, and just get document dot get element by ID, and just pass the input amount deposit ether. Okay, dot value, and just create another variable to get the instance. So just variable exchange instance, and just check that our deployed contract should be deployed. So exchange contract dot deployed dot then, and pass the function instance, and assign this instance to our exchange instance variable. So that is exchange instance, and that is equal to variable, that is instance. Okay, after that I need to pass this value of ether in a V from that particular account. So I will write down the exchange instance dot deposit ether, and I will pass the value here, that is a value, and in this I will pass this the value that I got from web3. So web3 dot convert to V, so to V, and pass the amount of ether and text ether, and just pass another, that is the account, from this account, and return this instance. Okay, and just return this. After that what I need to do is that if this operation becomes successful, I will get the transaction result or hash. So for that I need to write down this then function here. So dot then, in that I will say transaction result, and in that I need to refresh the exchange balance after the depositing of the ether, right? after the first function successful, then I will refresh the balance exchange here and just get the document element ID, and after the refresh just blank your input box there. So write down the code here that the input deposit ether dot value and make it empty. Okay, and if this all condition fails, okay, I need to write down the catch for this. So catch function E, and just console the log here, and just say self dot set the status to of that self variable that we are getting error for the balance, right? And see the log. Okay, so this is the deposit ether function. So after that we need to write down the function for withdraw ether also, and withdraw ether function will be the same like the deposit ether. So what I can do is that I can copy this, okay, so just make the spelling mistake here. Okay, now the spelling mistake gone. So just copy this now and paste it here and change the name to the withdraw ether. Okay, the function will be the same, just need to change the text here. So here you need to write down the withdraw ether. Okay, so change those things here. So here I'm checking the Web3 ether that how much ether I need to withdraw from that particular account. So I mentioned it here. Okay, and just change the text here, that is the deposit. Change this to withdraw ether and copy this and paste it here. Okay, so other things will be the same. Okay, so this is the function for your deposit ether and withdraw ether. So in the next lecture we will write down the function for our deposit token and withdraw token. So right now, thanks for watching. Hello everyone, so we will continue with our app.js file in this. So in the earlier lecture we have already written the function for our withdraw ether and deposit ether. Okay, so now I need to write down the function for our deposit token. So we can write down the deposit token function. So just write down the deposit token function here, and in that I need to get two elements for that particular value, that is the amount of token I need to pass to the contract token, a contract, and second thing is that I need to pass the token name to the contract function, that is a deposit token function. So just get the element here, input amount deposit token, and just get the value. Okay, and for the name also, that is name, that is variable name. Okay, and after that I need to deploy my exchange contract and take its instance. and so just deploy and take instance. So after our exchange deployment, we will get the instance here. So this line will be the same as we have already done in the above code. So instance, okay, and in that I will assign my instance, that the exchange contract instance, to this exchange instance variable, and after that I will call the deposit token contract function using exchange instance dot deposit token, and in that I need to pass these values. That is the name of the token, that is a name token variable. After that, amount token, and from which account, and the gas amount that I need to pass to deposit this token. So I am passing the static value here of the gas, that is a 4500 5 times 0. Okay, so after this, just return this, and if this operation becomes successful, you will get the transaction hash, the transaction results. So just write down then and write down the function that is a transaction result, and just console.log your transaction result for more information, and just refresh your balance. Okay, so refresh your exchange balance using this, and if this all function becomes, or if there is some error, then just try to add the catch function and log your errors there. So just console log e and set status. From this, just copy this and paste it here. Okay, so this is the deposit token function, in which we will passing this name of the token, amount of token, and the account from which we need to deposit. Okay, so just like the same way, I need to write down the function for withdraw token. So what I can do is that I can copy this code, because this code will be also the same. So just let me copy this function here and paste it here, and just change the names here. That is a withdraw, okay, just change the withdraw instead of deposit. Okay, and add the one line, that is a app.set status here. After this instance, that is app.set status, that is initiating the withdrawal. Okay, and here I am just withdrawing the tokens. So for that, I does not need a gas, so just change the text here of the method, that is a withdraw token method, and remove your gas value from this, and other things will be the same. Okay, so after that, we need to write down the input withdrawal token value and make set it to the blank. So for that, I need to copy this, paste this, and just set this input box value to blank after the operation. So I am making it blank here. After that, I need to write down this app status, that is the withdrawal complete, to just change this to the complete, and other things will be the same. Okay, so this is the function for withdraw and deposit token. So in the next lecture we are going to add more function into this file. So thanks for watching. Hello everyone. So in the today's lecture we are going to continue with our app.js functions. Okay, so in this I have now copied some predefined functions from my file. Okay, so these are just to check the token balance or update token balance function and the watch token events. Okay, so this just the update token balance function will update the balance of the account for that particular call, and the watch token events will just show the whatever events that get fired from the contract will be shown onto the front page. Okay, so but we are interested to write down more function regarding the token exchange, right? So for that I need to write down new function, that is for add token to the exchange. So add token to the exchange function, and in that I need to pass three values here, because this is the add token function from the contract. So if you remember, so add token contract actually get a token name, or you can say token symbol, and the address of the token. Okay, and the things like that. So just get the element here, that is the input name token add to exchange, and get the value and okay, and after that just create another variable to store the address and get the value from get element by id, that is input address token add to exchange, and get the value here. Okay, so just add the value here. Okay, and now I need to check with my contract deployment here. So just write down exchange contract, check that deployment, that is with deployed, and write down the then function to get an instance. If I get the instance of this exchange contract, then I can call with that instance the main method, that is the add token, that is present in our exchange solidity file. So just write down instant dot add token and pass this value, that is the name of the token, and after that the address of the token. Okay, and this third is the from which account. Okay, so if this becomes successful I will get, okay, so if this operation becomes successful I will get the result hash, that is my transaction hash result, and that I can check and set the status. So I need to write down the code that we have already known here, that is console.log, and just pass your transaction result and just set app status, set status, and just add token, that is token added here successfully. Okay, and just write down catch statement. If the operation above fails, then we can log the error here. So for that just write down the code for that. and set the status, that is error. That is error getting balance. Please see the log. Okay, so now we're done with our add token exchange function. So like that, I need to write down the function for send token. So write down the send token function, and in that I need to declare, I need to write down the code. Okay, so first I need to declare the variable, that is the amount that we want to send. So just get that amount using parse int. Okay, so just parse int is used to convert that value to integer and store that into your variable. And get the value using dot value. Okay, and after that just copy and paste this and change it to receiver, change variable. Okay, and remove this parse int line and keep the other things as it is. Okay, and after that what you can set the app status is that initializing the transaction using the app.status. So write down the app.set status and pass whatever the message you want to pass to the user, that is the initializing the transaction. Okay, and after that write down another variable, that is a variable token instance that we required to get the instance in that, and write down the code to check the deployment. Okay, so token contract, so this is token contract, not the exchange contract. So token contract dot deployed dot then, and the function instance. Okay, and in that I will pass this token instance is equal to instance, and I will call from this instance the transfer function. So that is a token instance dot transfer, and pass our values, that is the receiver, amount and account. Okay, and then if this operation becomes successful, what I can do is that I can set the status to the transaction complete, and I can update the token balance function that we have already written above using app dot. First of all, set the status here, so the transaction complete, and after that write down the app dot update token balance. Okay, and if this operation fails, again just add your catch statement to log your errors. So set status and just write down your, or copy this and paste it here. Okay, and return this. Okay, after that we need to write down the other function, that is allowance of the token function, and that is the same like your send token function. So you can copy and paste this send token function. So just copy this and paste it here and change the name here, that is allowance token. And in that all the things will be the same, just change your text inside that. Okay, and all things will be the same, just instead of transfer function we need to call the approve function. So just write down that thing there, and other things will be the same as it is. Okay, so this is the allowance token function and send token function. So in the next lecture we will write down the more functions. So thanks for watching. Hello everyone. So in this lecture we will continue with our app.js file. So in this now I have to write down some trading functions. Okay, so that I have already copied and pasted it here because the code is very large, that's why I copy and pasted here. Some of the functions that like refresh balance exchange and print important things are already we have implemented in the above code. Okay, so in this code we have written down this update order books and listen to the trading events. So in this update order books and in the listen trading events I have just updated the order book function. Okay, so whatever may be the updates I just shown on the screen. Okay, and the same for our, that is the listen to trading events, that will be also the same. So just to show on our HTML file. So okay, but we are interested to write down the main function for like sell token, okay, and buy token. So we are going to write down the function for sell token. So this is the important function. So just write down the sell token function. So sell token function, and in this I need to pass 3 values, and for that I need to create 3 variables, that is the token name, amount, and at which price I want to sell, right? So for that I will declare 3 variables here. Okay, variable price, and what I will do is that I will use the get element by ID and get the value from there. So input name sell token, and just get the value. Okay, copy this line and just paste here. Okay, and here. Okay, so just change this to amount and the prices, that is amount, and last one is the input price. After that I need to write down another variable to store my instance. So write down the variable exchange in this, so variable exchange instance, and after that I need to write down the exchange contract deployed and then function, check the deployment and do the to get the instance. So function instance, and in that assign the instance function to this exchange instance here. So exchange instance to instance, and now call this sell token function using exchange instance. So exchange instance dot sell token. So this function is present in our smart contract, and then pass your token name, price, and amount. Okay, and also we need to pass the account, so using from account, and I need to pass the gas, so I am going to pass the gas value here using 6 zeros. Okay, so this is a static gas value. Okay, so if this and just return this. Okay, and if this operation is successful, then I will get the transaction hash, that is a transaction result, and I will just need to refresh the balances of an exchange, and for that I need to write down this code. So just update the app.refresh balance exchange and app.update order books, so those things will be updated from here. Okay, and if any error comes, so we will catch that in here, and we will log those using the console.log, and we will set the status to error like this. Okay, so just remove this. Okay, so after that I need to write down the function for buy token also. So this function will be the same, so I can copy and paste it here, the function. So just copy this function and paste it here. So this function will be the same. So all the variable, amount, token name, price will be the same. Okay, just change this here. And change the sell token to the buy token. Okay, and all other things will be the same. Okay, so this is it with our app.js file. Okay, and after that what we need to do is that we need to save this file and go to our index page .html, and in that we need to call this script here. So just I have already copy and pasted that script here, so just I am calling the app.js add event listener on each and every file, like index.js, html, manage token.html, and trading.html. okay, so already I have done this. Okay, so this is it for the front end. So now we have done with all our app.js and other things, and index.html and other files. So in the next lecture what we will do is that we will run this code, and I will explain that how our exchange will work according to our code. So thanks for watching. Hello everyone. So in the today's lecture we are going to run the project. Okay, so for that we need to click in this region and open the terminal. Okay, after that we need to first of all compile this code. So just write down the command truffle compile, so it will compile our code. So it is now compiling all the smart contracts. Okay, after that we need to deploy this, so using truffle migrate command, so that will be get deployed on this ganache here. So I have already opened this here, so this is already here. Okay, so it is deployed here. Okay, now I have to run this using npm run dev command, the browser. So now it is running. Okay, so just copy this link here and open. So right now it is opening here. Okay, so this is our project that we have successfully run, and these are all my active accounts and address exchange and address token that I got from my MetaMask. Okay, you need to activate this MetaMask before run this project. Okay, if you don't, you will get an error, or you will not get any active accounts and anything like that. So for that, just I have mentioned earlier, you need to go to your Chrome store and download this Chrome extension into your Chrome. and then just insert your password, open your Ganache and import those accounts, okay, from the private key. Okay, so after that it is set now. So I have already set it here. Okay, after that I need to go to this token management page, and here you will find I have this amount of number of tokens in my account. Okay, those tokens are actually in my MetaMask. Okay, so now I need to add some token first with some name into my exchange. So I am giving the name to my token, that is my symbol name, that is the name of the token, and I am going to do that on this address, that is my address, token address. So copy this address and paste it here, and just click on this add button. So the MetaMask notification will be open, and it will ask you to pay some gas to add this to your exchange. So just confirm this, and here you get the confirm transaction successful. Okay, now token is added also. Okay, so now we need to approve the token allowance here. So I will approve 10,000 tokens or 1,000 tokens here. Okay, with this added exchange. Okay, and just allow here, and we will get the success. Okay, after that we will go to the exchange page, and here we will try to add a fixed amount of token here with 1,000 token. It will ask you for the gas price, and okay, so now my refresh page, and now you can see my 1,000 token is added in my exchange. Okay, after that I will deposit 2 ethers here to the exchange. Just confirm it and refresh the page. Okay, here you will see the 2 ethers actually now in my exchange. Okay, after that I am going to withdraw some tokens, that is symbol name, that is I am going to use a fixed. So okay, so just write down the fixed, and we will withdraw 500 tokens or 100 tokens, and withdraw the tokens, confirm it. Okay, now you can see my transaction complete, and here you will see 900 token. So my 100 tokens are actually withdrawn, and now I'm going to withdraw ether also. So just click on 1 and confirm it, and I'm waiting for the transaction to be completed by the MetaMask. Okay, now it is completed, and now here you can see after refreshing I have the 1 ether in my exchange. Okay, so this is the deposit and withdrawal functionality for our crypto exchange. Okay, after that I need to go to my token trading page. Okay, first of all I need to buy some token. Okay, so I need to add the fixed here. Okay, then I'm going to buy some 50 tokens for the 1,000 amount in EV. Then just click on this buy token, confirm it, and refresh the page. Okay, so here I got that I am buying the 50 tokens at the price of 1,000. Okay, now there is no actually seller now present in my page or in this exchange. Okay, for that my order right now is my limit order here. Okay, so for the scenario, if the another seller comes in, okay, and he wants to sell some fixed amount of token, okay, like 20 for the price of 400. Okay, and if he enters into the exchange, Okay, so I need to wait for the transaction to be completed. Now it is completed successfully, and now here you can see that my in my order book, my 20 tokens is getting subtracted from my 50 tokens. Okay, so the same way I can buy 200 tokens if there is a seller that he wants to sell 200 tokens for like 10,000 V. Okay, so and if he entered into our exchange, okay, here we find that there is a bid for this amount in the order book. Okay, for in the bid. Okay, so there will be no order execution like market order right now, and here you will see that my new ask order will be for 200, and if any buyer comes and he wants to buy 200 tokens at the price of 10,000 or more, then this will be executed. Okay, so this is the way by which the crypto exchange actually works. So this is the buy token, sell token, order things. Okay, and this is the order book where all the things will be saved as a limit order or market order. Okay, and these are all the events things. Okay, so this is the crypto exchange project. Okay, so thanks for watching. Congratulations on completing this project, that is how to build decentralized crypto exchange operating on Ethereum. So in this project we have seen that how we can build and how we can build the things for exchanges using cryptocurrencies, okay, using blockchain. So that we have learned in this project. Okay, so in this project what we have covered, so this is just a recap. In the first session that we have covered is that the basics about the blockchain, the basics about the smart contract, the history of blockchain, the features of a smart contract, so what it actually provides, and how this language actually works. After that we also saw about the Solidity basics. Okay, what is the syntax, what is the compiler that we use in that lecture, right? So we also saw some things in the second sessions, like what is the ERC20 token standard, okay, and how actually it works and how it helps to generate fungible tokens in a cryptocurrency exchange or normal tokens, right? After that we also saw the fixed supply token contract. Okay, after that we also see the definition of exchange and how exchanges works, and what is the sell order, buy order, theoretical things. Okay, those things also we saw. After that we implemented the basic functionalities, the basic functions like add token, withdraw, deposit ethers and tokens. Those basic functions we have implemented in session 2. After that we also saw the difference between the market order and limit order, right, in the session 2. Okay, and in the session 3 what we have learned is that how to install the softwares like npm, truffle, ganache, right? And in that we also see that how to write down the exchange smart contract, right? What is the variable, what are the mappings, what is the struct. Okay, that after that what is the truffle file structure, actually what it contains, right? We write down some smart contract like exchange owned file, fixed supply token, right? After that we also added the functionality of add token, and all the contracts like buy token, their functionality, all those things are that we covered in those lectures, right? We also saw in the session 3 is that how to write down the test cases, how truffle test structure actually works, and we also wrote down fixed supply token test case for an example, right? So we saw all those things in the session 3. And in the session 4, what we have done is that we build an front end for our smart contract. So from the front end we can interact with our smart contract code. From front end we can pass the value to the smart contracts, like to deposit ether and other things. Okay, so all those things like app.js file we have saw in session 4, right? And after that we compile that project, migrate that project, and we run that project successfully in this session 4, right? So this is how actually we gone through this course. Okay, so if you have any questions you can ask us anytime, no problem in that. And thanks for watching my course.